Welcome to our continuation of week 4 of 7MMC, the 7th Mario Maker Celebration. We did most of the levels in this week's set of 8 a couple of days ago. This is number 7 that we're currently on, which we didn't finish last time despite spending well over an hour on it. Much to my consternation, and perhaps much to the embarrassment of the reputation of this channel, given that in the past we've done quite a few puzzles and cryptic escape rooms without too much trouble. This one, we ran into a wall pretty early, and we were also encumbered by, I think, a less than ideal note-taking style, which we're going to try to correct this time around. We discovered last time that popping in and out of this level and back to the editor works pretty well for illustrative purposes, despite having to redo some of the early content as we go. So we'll do it. The codes for 7MMC are, as before, on the website right next to this week's beautifully animated trailer. But let's get back into this, let's get back to the dead end, and we'll explain what we did wrong last time and try to correct that mistake with a new insight that I had literally 5 minutes after logging off of the previous stream. And this time we're also going to start with the Nintendo Switch Pro Controller right away, which is unusual for me because we do need the full range of controls for the editor as well as potentially the screenshot button. So this time we are coming in prepared. Anyway, this level is purely a sequence of combination locks. It's all about finding the right order of activating the skull platforms. The tutorial segment here tells you that you just read the snacks in order. 1, 2, 3. And 1, 2, 3. Pretty simple so far if you read the MTP blocks that way. And here's coin number 1. Now, we went down a couple of blind alleys when it came to interpretation, but we ultimately determined that the question blocks are kind of a masking wildcard element. Whatever the question blocks are obstructing, you don't know what's there. It could be empty space, it could be the MTP block, it could be anything. So you have to determine it by constraint satisfaction, and we know that if we have a 1, 2, 3 in the solution space, we know that it must be the 2 column. Yeah, Lupin Snoop, I spent way too long on this one in the previous stream, and then 5 minutes after I logged off, I realized that I had fundamentally misinterpreted one of the clues. And so I think we should be able to do better this time, but we'll see. And I hope you have otherwise also been well. I know you've been dipping into some other stuff like Cult of the Lamb. Anyway, we know that this is going to be 2 and exactly 2. And this cannot be 3 because the top space is empty. Therefore, 1, 2, 3. And Wort Ted, welcome. Alright, we know from the middle tile here that because the second tile is empty, the second from the bottom, this must be 1. This must not be 3, so it must be 2. This is 3. You've been spending a lot of time remodeling your new house. Congratulations on your new house. I hope it's been a lovely space to work with. We know that because the second row from the bottom is filled on all these 3, this must be 1. This must be 2. This must be 3. And 4. Moving, remodeling, all the while judging for 7MMC. Yeah. It's funny that you mentioned that because I vaguely recall that when Kavik was working on 6YMM, he was also doing something similar. Like, he was always talking about knocking out walls for a new home theater setup or something like that. This must be 2, 3, 4. I didn't take notes for the section before CB1 because it's pretty easy to eyeball. Once you've done this a few times, you kind of develop an eye for the geometry, at least with basic configurations. Okay, so here's where I ran into trouble last time. I said last time that I kept referring to the ice block as a bomb because it looked like it had that same cross configuration as a normal bomb. Except, of course, a normal bomb would reach further than that. It would reach 2 tiles. But it had the kind of cross configuration that I think I associated with the bombs in games like Into the Breach. And so I kept thinking of the ice as destroying the surrounding tiles around it, when that's actually the wrong way to think about the ice semantics completely. And I'll show you what happens when we do that and how we're going to correct that mistake. Because this, I realized I said immediately after I logged off the other stream that I had just completely misread what the ice block was doing. We're Ted. I've been doing fine. Hoping to get a little further in this puzzle than I did on a previous stream. And 1, 2, 3, 4, 5. Yeah, you see, Loop, as far as having help goes, I mean, that was sort of the intent behind the 5 and 6YMM to begin with, I think, was that it only happened in the first place, I think, because Kavik was telling himself going in, okay, I'm going to delegate, I'm going to step back to more of an executive producer role, I'm going to do all that. And it turns out that despite delegating a lot of things and decentralizing a little bit, he ended up doing 300 hours of playtesting anyway, and I think at that point he realized 7MMC, or rather 7YMM, was going to be untenable for him, and hence 7MMC in the form that we have it, and I think it's in splendid form so far. So, big congratulations to the organizers of this event for having made it a success so far, from what I can see. So, we know that with my previous interpretation where the ice was a bomb element that destroyed the blocks around it, that 1, 2, 3 here still worked. As we'll discover, that interpretation does not work, because it doesn't create a sufficient constraint. The interpretation we should be applying here is that the ice actually always forces each of the adjacent squares around it to be filled. So I'll illustrate that in the editor when we get to the editor. This run is going to be bust. And here we go. Anyway, so we had no trouble until the 5x5. Because my interpretation of the ice as a kind of cross bomb affecting the single tile around it worked perfectly well. Worked absolutely perfectly well for everything that I was trying to do with it, including interpreting the question block here as an ice block. And so I just kind of went through this whole segment here, had absolutely no idea that anything was wrong. This one we need to get out the notepad for. Let me show you. This is our escape room notepad. And we determined, using this grid here, that the bottom block couldn't be empty. It had to be either a regular piece or ice. And so we determined that the bottom question blocks in either one of these columns is ice, and the top one is not. The top one is, in fact, nothing, I think. No, the top one is, in fact, a P block. My zeros here are actually meant to be the empty P block. I should have used P for that, but oh well. We'll fix that later. Let's turn off notes, and let's punch that in. So, ultimately, what we managed to do was get 1, 2, 3, 4. Now, this was where we ran into trouble, and this is why, this first attempt here, we're just going to blow it, we're going to exit. I'll show you what this looks like in the editor, because that's sort of essential to presenting a solution. So, this is the only thing I've looked at off stream since logging off in a previous session. I basically had a theory for what I did wrong. I went to the editor, I checked it out, I created a new solution very quickly. I came back here, I tested it, and it worked. We're going to go to the editor and show off what that method is. And Mario Roiru is having issues with this one. So yeah, for those of you just coming in, and Mario, Meng, Luca, as I was just saying, I logged off this level 2 days ago, having gotten jammed on a 5x5 grid at the very end, and then I realized very quickly how I was interpreting the ice block and why that was wrong. So I'm pretty sure I have the correct approach to the ice now, and we're going to go to the editor and show that off. Okay, so this is our workspace previously. we created this diagram to show off the grid we were working with. We tried to test some solution spaces given my previous theory, which was the idea that the ice destroys the four spaces around it and empties them out, kind of like a bomb that creates a cross pattern. We quickly discovered that this doesn't sufficiently constrain the puzzle. I tried punching in solutions like these, but there was no way to actually create a contradiction with either one of these solutions, given my interpretation of the ice block. And since we couldn't create any contradictions, we couldn't explain why this didn't work. So, it turns out this was a mistake. Previously, I was thinking that if you had, like, a cross pattern like this, or anything around it, then you would just plop in the ice block, and you destroy, and you destroy the surrounding pieces. But it also meant that I could have, for instance, something like this, with an empty space. And I would pop in the ice... Sorry, let's see here. I'm terrible at the controller interface, I'm so used to touchscreen. I'd pop in the ice with, say, this interpretation, and I assumed it would still work. Or maybe we have this interpretation with nothing on top, and I assume that would work. This was the problem. So, I'm assuming each puzzle is not affected by the blocks in the previous puzzle. Yes, because so far we have not seen anything to contradict that. It seems like I need one consistent semantic scheme for every class of block. And so that's the approach I'm applying here, is that each puzzle is completely independent of the previous ones, but the puzzles are giving you information about how to interpret the rules by specifying additional constraints for how these elements must be interpreted. So by the time we reached the 5x5, I realized that the interpretation of ice that I had worked completely fine up to that point, but was no longer sufficient because it produced bogus solutions like these ones that didn't function. So here's how you interpret the ice instead. Every time you see the ice, you assume that it actually creates a full cross. And this actually solved everything. Now, the cross could also be something that's masked by a question block when you see it elsewhere. It could maybe be initial ice block, I don't know. But you assume that when you see the ice, that everything around it is definitely filled. Not probably filled, but definitely. That instantly made this much simpler. Whereas previously my method was to think about a series of constraints that looked like this. I was thinking of something like this, where I was telling myself, okay, we can start from the left and work our way forward because we know the one on the left is definitely not 5, since you have no way to account for the top left corner. So I was thinking, okay, what happens if it's 4? What happens if it's 3? What happens if it's 2? What happens if it's 1? And that leads you down a massive branching tree of possibilities that is significantly more complex than any of the grids that we've seen so far. I should have noticed at that point that something is wrong, because if you interpret the ice as something that must be a cross, that actually instantly gives us a very specific constraint, which is this. Rubens level gives you a great idea for a not at all toxic Garbo level. Looking forward to that on your Garbo account. A code that I actually have to recover because I don't think I wrote it down. Although that shouldn't be hard to find on your YouTube, perhaps. Or I could just ask you. Alright, let's first of all get my cursor going again. Alright, let's get rid of this thing. Let's multi-grab this thing. Actually, you know what? Let's just nuke these. No. Yeah, let's just nuke these because these solutions are bad. And we'll be careful here because we want to leave the semi-solid in place. We'll use this as our workspace down here, in fact. Okay, so we know that these spots here are all emptied out. And we'll just leave them as a void for the time being, although maybe it's better to specify that somehow. But let's just maybe fill this in. And I'll show you how this goes. This is a much better note-taking style than what I was using previously. Much faster. Don't have to deal with white space. I've been avoiding spoilers, so I don't know how other streamers have been diagramming these, but I assume they have been diagramming these in some form. Okay. Loop the things you memorize from sending Garbo to streamers. Exactly. So, here's the constraint I was talking about. Suppose that ice always makes a cross. Then you know ice cannot be... Whoops. Come on. Then you know ice cannot be here because it would have created something here where there's empty space. No, actually, no, that's not true. What am I talking about? I completely blew that explanation. That's not true. What was I looking at? No, the reason that I know that... okay, no. I confused myself for a moment because I absolutely had this. I'm just trying to recover what my explanation was. So, supposing that ice makes a cross. You know that only one of these columns can be 5 high. There was a particular reason I came up with that you know it must be this. And I think I know why. Because otherwise you would have multiple columns that are at least 4. So, let's say you have ice here, or here, or here. It cannot be in any of these locations, and this is why. Because each of these locations creates a situation where 3 different columns are at least 4. So, for example, you might have this configuration, where you have height 4, 5, 4. Impossible. You can only have at most 2 columns that are at least height 4. One of them is height 4, one of them is height 5. Therefore, you know that in the top row, the only question block that can be ice is this one here. None of these can be ice. And only one of them can have height 4. So, here, we suddenly have a very specific series of constraints. Because we know this must be 4, we know this must be 5. And we can take these 2 out immediately. So now we're just down to the 3 columns to the left. And in fact, we know that we're working with this. And so these 2 essentially don't matter. They can be P, they can be ice, they literally do not matter. And this one doesn't matter either. So now we need to determine, and actually, it might matter. Let me think about that. It might matter because they might be height 3. We know this one is. Actually, no. Let's step back. Let's not make that assumption. It's possible that maybe you had ice like this. Ice takes out ice. Ice takes out a block. Because then you have like a column that's 3 high, and then you would have something like this. That's possible. So never mind that. I was wrong once again. But anyway, we know that these 3 have maximum 3. And that we're going to have to deal with them somehow. We do know, however, that we have that previous constraint that we were talking about in my notes from the previous session, which is that the leftmost column must always be lower than the second column. And the reason we know that is, well, first of all, because we know that this cannot be 4 high. This is definitely not ice. At most, it might be this, but it's definitely not ice. Because ice would have created something above. So this one is going to be either a P block or nothing. Let's erase some of this stuff so we avoid confusion. In fact, it's probably better if I start specifying some of this stuff with question blocks instead. Again. So yeah, we know that at minimum this is going to be P, but these might still be ice potentially. So let's say we've filled this out in case this is ice. Because if these are ice, then... Whoops. Come on. You got question over here. But anyway, we know regardless that this is going to be 4 high. This is going to be 5 high. So we have some kind of configuration here that's going to be 1, 2, 3 distributed over these 3. So we can basically iterate over the possibilities. We know the leftmost one will not be 3. And the reason we know that is that if it were 3, then it would have needed to be destroyed, or not destroyed, but like implemented using an ice block here that would eliminate this space. And in fact, it would need a continuous ice column in order for that to work, because it would have removed all these parts of the cross. And that would create a tower that looks like this. And we can't have that, because that, once again, creates too many columns that are too high. So, that's definitely not going to be it. So now we suppose, okay, what if we have this configuration? Then once again, you have a problem where at least 3 end up being height 2, and you have no room for something of height 1. So we know we can eliminate that. So we know that of these question blocks here, this cannot be ice, this cannot be ice. I need some kind of additional denotation of that, perhaps. So we know then that this could be 2, it could be 3, but it's definitely nothing else like what we've seen here so far. So then you think to yourself, okay, is it... And because of that, we know that the only way that this could be 3 is if you have ice block over here, which I would also require ice over here. But so far we've seen no evidence that ice block can remove another ice block. I think we always just think of it as a cross. So depending on that constraint, we can remove this further. Anyway, let's get back to this scheme here. I definitely had this solution. I'm just trying to reconstruct it, try to understand what I did. Because I didn't write down my answer, actually. I know I tried it and it succeeded, but I wanted to reconstruct this on stream. So let's see if we can actually work through the reasoning here. So we know that not all 3 of these can be 2. One of them has to be 1. So we ask ourselves, can this one be 1? Well, if we have something like this, then yes, it can. So we ask ourselves, well, then can this one be 1? If it is, then can this one be 2? Only if we have an ice block down here. Okay, so we need to constrain it somehow. We've got 4 and 5. But we know that these squares here, this one, this one, this one, came out as empty on the grid. And so if they are filled, they must have been eliminated by some surrounding ice like this. Or perhaps like this. That also works. They must have been eliminated somehow. And this one must have been eliminated by ice. Either here, and not here, because once again, it creates too many columns. So we have this configuration here. Now, this one we can just do as is. But basically, this one can be ice, or like one of these 2 will be ice. It actually does not matter which one, I think. And that's in the event that this is a 2. If it's a 1, that's a different question. If it's a 1, then we just wind up with something like this. But then we wind up with this one as 2. If this one is 2, then that creates, once again, the ice block constraint. That's a problem. So I think the only way that this can be 2 is if you have the ice block on the bottom which exists in this grid in a way that was not previously the case. So I think we have it. It's going to be 1, 3, 2, 4, 5. And we're going to write that down. We're going to go 1, 3, 2, 4, 5, and I believe this is correct. And I think this is actually going to be what we're looking at, although once again, as I said, it's actually a little bit underconstrained in that either one of these ice blocks could have been not an ice block. You just need one of these to create this space over here. And as you can see, the ice can be adjacent to other ice. So that's something to keep in mind, is that that's part of the rule set. With that in mind, let's get out of here. Back to Course World. Let's get back in. Let's punch in a whole level once more. And we'll see this time if we can progress. And we'll have to do it a little faster with less talking than the last time because I was already running up against a time limit. So, let's just try to visualize it. And once again, if the later puzzles require me to do some notepad work in the editor, we will have to edit blocks again and exit the level from scratch. That's okay, it's pretty quick to do this, even though the world record currently is 3 minutes. So, likely, if we're assuming that each of the solutions is independent of the others, the approach that I'll take is I'll actually screenshot what I can and do as many solutions together at once using the editor if we run into anything particularly thorny, like a sequence of solutions that are all relatively complex. So we'll be thinking ahead when it comes to some kind of strategy for managing this. Anyway, as before, these are all fairly easy to constrain. Pretty easy to visualize as well. Okay. Now, it'll be funny, perhaps, if I punch in a solution that I've just spent half an hour reconstructing and explaining, and it turns out not to work. But look at the ice block here. You can see that consistently, you can interpret every one of these ice blocks as creating a cross around it, rather than destroying it. And it works. You can just visualize each of them as having completed the spaces surrounding. So it is one of those instances where, of course, as I was saying earlier, it works perfectly well with my wrong interpretation all the way up until you get to the 5x5. But then that's what we would expect to have happen when you run into solutions of greater complexity, is that perhaps it illustrates that our rule set was insufficiently powerful and we need to make some kind of adjustment. Now let me take a look at my notes here for this one. It's going to be 1, 2, 3, 4. Okay, here we are. So, the solution I wrote down here earlier was 1, 2, 3, 4, 5. Correct. So, here's progress. And Killer Chronic. Welcome back. Okay, we are in new territory, and here is something new. We have the empty blue P blocks. I think we still read this as 1, 2, 3. And as you can see, the empty blue P blocks work as a kind of negative space, where having anything underneath them is optional. There can be a P, there might not be a P, but you kind of think of them like a waterfall structure or some kind of negative space that says perhaps that it must be empty. I don't know how it's going to interact with the ice blocks. Perhaps if you read the empty blue P blocks as saying this space must be empty, then it allows the rest of the layout to be ambiguous, perhaps, and it'll still function. So the thing that I have to think about is what happens if you have the empty blue P next to an ice block, for instance. What does that collision do? Because I feel like we're going to run into that pretty soon. Anyway, 1, 2, 3. So you know that this is 2. Now notice that with these previous interpretations, we're also kind of constraining them in that, are we thinking about the left column, for instance, as maximum 2? Or something that must be 2? I feel like because the 2 spaces down below are ambiguous and empty, that we're actually reading this as maximum of 2. And we're just realizing that it must be 2 because this must be 1. And therefore this must be 3. Because here, if we read the ice as before, then we know that it's going to be 1, 2, 3. Because the ice creates a cross that is definitely filled. So we're going to read this as 1, 2, 3. And once again, okay, so here's the interaction we were kind of speculating about earlier, is what happens if we have the ice next to the blue block. Ice here tells me that this must be 3. This interaction tells me that the ice creating the cross is cancelled out by the blue P block, because normally if that space is empty, then the space to the right of the ice, given our previous interpretation that got us through the previous room, is that the ice would create another empty P block on top here, and so you would have another column 3. So the priority order is this. We think about the ice as a cross that is placed first. And then we think about the blue, the empty blue block as a deletion that kind of negates that space. And that makes it 2. So it forces an empty space after the cross has already filled it. Let's think about it that way, because maybe we have resolved the rule simultaneously, but if we kind of think about it in terms of an order, where the deletion that of the space that is emptied out by the blue block kind of takes priority over the ice cross, then we have a pretty clear collision order. And I feel like that's something that we need to jot down in the notes, for sure. I need to clean up the notes, in fact. Let's go for it, but we'll definitely clean up the notes to jot that down, because I feel like that rule set is absolutely vital. Anyway, 7MMC. We haven't discovered a secret so far. I assume there's going to be a hard puzzle behind it, and regardless, this is checkpoint 2, with 90 seconds remaining. So, before we go on, let's jot something down. Okay, let's trash a bunch of the stuff that at this point is just junk. Because we have the editor anyway. And we had a couple of blown solutions in the previous grid that were bad ideas. And yeah, this stuff is still kind of true, but we're deleting it anyway. Let's clean up. Just so we don't run into issues with our own notes. So this is the thing I jotted down at the end of my previous stream, which was the ice never removes empty space. That's kind of true. So we're actually going to start writing down some of the semantics here. Question block. Okay, let's type rules. Could be anything. The empty P is definitely filled. Let's create a table here. We have the ice, which is creates MTP cross. I feel like MTP is a bad way to designate that. Creates P cross. Unless we have filled P blocks later, let's just call them P. because we're going to run into trouble otherwise by thinking of them as empty. Let's say blue. Blue. Definitely empty. And we'll go priority over ice. Okay, let's do that. So this is our current effective rule set, and we're going to use that as our guide. And I'll leave this diagram previously since we didn't sketch it out in the editor. So, with that in mind, let's get into the next segment here. And okay, so we have this pattern where the top 3 could be anything. Now, note something really interesting here, which is that you know that each of these have a minimum height of 1. But that if you have the question mark occluding one of the blue blocks, we're just going to call the blue state blocks, even though they are empty, then there's that kind of waterfall effect where, you know, everything underneath it can be ambiguous. So for example, if you imagine that the top left is a blue block, it could be 1, it could be 2. So the question we have to ask ourselves is, under what circumstances could this row be completely empty? Well, if the bottom right is ice, then this could be 1. If the bottom row is ice, this could also be 2 because perhaps ice has removed ice? I don't know. No, we don't see a reason to believe that, because I think even with the previous yeah, no, I think this has to be 1 then. And under what circumstances could this be 3? I don't think it can be. I think it must be 2. So let's imagine bottom right is ice, top left is blue. And we're going to go 1, 2... Well, we're at checkpoint, so we'll test that in a moment. So I'm imagining that top left is blue, bottom right is ice, because that interpretation makes sense to me. It is not. Okay, let's rethink this. And let's get back in here to rethink this, because that's wrong. And we don't want to just do trial and error with this, we want to actually properly figure it out. So basically we have to figure out where is the... So this empty column is interesting, because in order for it to be an empty column, it must have been eliminated by ice. Because we know from the previous room that ice doesn't eliminate the blue block. The blue block kind of takes priority over it. So, since ice doesn't eliminate the blue block could be top left, it could also be top right. We know it has to be somewhere, because otherwise... Yeah, because this could be 1 or 2, remember. Not just 2. This is 1 or 2. And this is going to be... Well, let's think about it, because we don't know. I mean, previously the evidence that we saw was that with the blue blocks, everything below it we would think of as a P block. We have no evidence that there could be something like an ice block below the blue block, for instance. At least I don't think so. We'll kind of... we can't freeze frame the previous screen because we're past checkpoint and past a 7 MMC transition. But for example, if you think of this as 1. And this could very well be 2, because if you think of the top right... Well, no. In order for the central column to be 3, either top left is ice or top right is ice. And we know that's impossible because that would create 2 columns that are 3. So the one in the middle must also be 1 or 2, and I think it's going to be 1. Wasn't this what we did earlier? Oh, okay, no, I just punched it in wrong. There we go. Yeah, okay. 2, 1, 3. We have to jot this down. Just one moment here. Let's do CP2, 2, 1, 3. Yeah, so that was actually pretty easy to read to note once I had it, because it was really the central column that was a kind of giveaway, because you can constrain it pretty easily just because you can't have multiple columns that are 3. Okay, this one. Well, we need to think about this. The top right square being empty, I think, is the major giveaway here. Because the top right square is far enough removed that we know this column on the right cannot be 4. It can be 1, it can be 2, it absolutely cannot be 4. So for this one, also notice that there's an exit pipe here, that if we need to sketch this out in more detail in the editor and exit all the way through to the beginning, we can probably take a screenshot of this screen and be done with it. Let's preemptively take one now. We'll try to sketch it out on paper first, though, because I think it's not really that complex. We'll just do a very quick sketch. So this one here, we have question, 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 question. So we have maybe column 1, 2, 3, 4. So this one is going to be less than 4. It can only be 1, 2, or 3. And we know because there's no way to actually fill the top right square. What about the bottom left square, though? By that logic, how could the bottom left square be filled? Well, the only way that the bottom left square can be filled is if you have a empty blue block in one of the top 2 positions. And so I'm wondering, so this also can be, I think, 1, 2, or 3, although the blue block counts towards the height, so this could actually be anything. This one on the left here, except we know that it's going to be a blue block in one of those locations. Because otherwise there's no way to actually clear the bottom left square. So one of these 2 is going to be blue, that means that this one is going to be 3 or 4. And if this is less than 4, let's do 1, 2, 3 here. Now, we can reason about what happens with either one of these scenarios. So, suppose that the question block here is ice. It cannot be ice. Oh, no, it actually can be. Normally, before we set a blue block, we would suppose that it can't be ice because it would create 3 columns that are all minimum height 3. And that would be a problem. But now we can suppose that it actually is ice, because if the block to its left is the blue block, which I think of as a waterfall for some reason, then this can be 1 or 2, and we just think of the top left as empty. That would mean this one is 4, and it's the only one that can be 4. It's only this and this that can be 4. And this one can only be 4 if the top left is the blue block. Which would mean that this could not be ice, because it would create, again, too many columns that are minimum 3. And then we'll need to think about this one here. My current interpretation is that top left is empty. The next one below that is blue. This one is ice. And then you have 2, 4, 3, and then 1. The way that this one can be 1 is if it also has a blue block. So, my theory And yeah, we're going to use P to designate P. We're going to fix the previous one, because otherwise this will get too confusing. I'm currently reading this as nothing. And then, so yeah, blank is just going to be nothing. And then it's going to be blue, ice. And this can be something. It's going to be a height 3 from something else. It could be ice. I think it actually has to be. And actually, this could be P as well, I think. No, it has to be ice because it has to destroy one of these columns below it. Not destroy, but rather create a cross. Because you need to fill in this, you need to fill in this. You don't need to fill those if there's blue, though. But if you have something that looks like this, then the solution that you have would be, let's try to do this, 3, 4, 2, 1. And we'll try it. It might be slightly under constraint. I'm thinking about an alternate possibility as well. Okay, so that's wrong. Because the other possibility was if you have the topmost one be blue here. Okay, so this is wrong then. We'll put a big no next to it. All right, let's do an alternate interpretation and see why this was incorrect. Because let's say this was blue. Oh, I see. No, I see what the problem was. That this spot here, like under this one is not 2. If I had ice in this location, then the spot next to it would be filled, and that would create 3. And so you would have the same issue that I had previously, except, no. I actually just mistyped. I mistyped my own interpretation of this one. So no, we're fine, we're fine. This is actually the correct interpretation. But this interpretation, as I said previously, creates something like this. Creates all this stuff. Creates this over the ice. Yeah, because we have to remember that even though I've notated blue with B here, the blue spaces are empty. That's the thing that was misreading. And so let's reset this because I actually did have the correct interpretation. I just punched in the wrong numbers. Notice too that 7MMC text using all of the different block types to denote everything that it does. 1, 2, 3, 4. So yeah, I actually did talk my way to the correct answer earlier, and I just jotted it incorrectly in my notes once I got to it. Okay, our screen is a little obstructed here, so I'll see if I can get a better view of things in this location. Since we are stopped by the scroll stop, it means that we're a little bit obstructed, but we'll try to jot this down in the notes so we have a clearer view of what's going on. And I'll also just try to get the note screen up again so we have this. Okay, this is going to be 4 digits once again. And we will this time have question. And then I gotta do a blank row of some sort here because as you can see there is a blank bottom row that we need to deal with, and we need to denote that somehow. I mean, you know that the bottom row is always filled with something because everything is minimum 1, so. Once again, we'll do this scheme here. and just create a constraint satisfaction diagram of some sort. So I did say earlier I'd pop out to the editor, but the reason we're not doing it is because with the 4x4 grids, I think I can just eyeball it in the notepad, and it'll be faster than repeating everything. Also, I totally killed the game sound. This is what happens when you pause a lot, I guess, that we just lose sound a lot. That's okay. That means that we can just work this out on paper and figure this out. So at minimum, you know that the bottom blocks are going to be PPPP in some fashion, but that they have been eliminated somehow. And so the thing we think about is how do those blocks get removed? So how do they actually get deleted? And the first thing we have to think of is that it is going to be minimum 1 in each of these rows. But that of the 3 question blocks up top, in the top row, only one of those columns can be 4 high. But that doesn't necessarily mean that only one of the question blocks can denote a block, because as we've seen before, if it denotes a blue block, then that could potentially be compatible. But we know that only one of those question blocks is going to denote something that is either P or ice. And we'll need to figure out what that does. We know then that this one and this one in the top row, these two cannot be ice. The reason we know that is because that would force this spot to be P. We know that's going to be a problem because that would create multiple rows that are 4 high. So because of that, I'm going to copy this out so we can actually manipulate it. We know that the top one is going to be ice. Actually, no, we don't, because yes, we do. Yes, we do. Because this blank space here basically constrains this and this away from being ice. Now, how do we avoid a trap of having 2 separate columns be 4 tiles high? Well, pretty simple. That's going to be blue. So this is maximum 3. So we know that column 4 is going to be 4. We know that this one here is going to be 1, 2, or 3. We also know that the top block here, it could be blue, it could be, it could potentially be blue, it could potentially be nothing, but it's definitely not going to be filled. So this one currently, we can also constrain it 1, 2, 3, and we can probably constrain it further. Because we are now going to look at this slot here. I hope the highlights are actually visible. Let's blow this up a little bit. We're going to look at this spot here now. Because we're going to consider, first of all, can it potentially be ice? No, it can't. Because that would create a P block on top, and that creates a column of 4 height, and we know that's no longer possible. And would also create an additional column that's 3. That's once again going to stuff this space a little too much. But we do know that we need to deal with the bottom left corner somehow, because once again the bottom left corner is exposed in such a way that it forces one of these two to be blue. Because currently, whoops, the bottom row once again is emptied out. Because it's emptied out, we know that the bottom left has to have some kind of blue block above it. And that still doesn't constrain this enough though, because either one of these could be blue. So it's still going to be 1, 2, or 3. Turning to this one then, we know this one can't be ice because that would create another column of 4. That's not going to be possible because of the space above it. So then we ask ourselves, we have to ask ourselves what empties out all of the bottom row in each case. Because right now we're trying to find the 1. We need to figure out which one has to be 1. So if we know that this is ice up top, and we know that this is not ice, and we know that this is ice, it pretty much has to be, because if this is P, no, that's not true, because if this is a blue block, this could just be an empty space just for the heck of it, and so that actually doesn't tell us anything. Yeah, the blue blocks actually introduce quite an additional layer of complexity here in terms of figuring out where these constraints are going to go. However, we do know that this corner has been taken out. And that because this is height 4, this cannot be blue, this cannot be blue. Therefore, the only thing that can remove this block is ice. And then this becomes P. This is still ambiguous, but we'll figure that out in a moment. So that means that ice creates P over here. We now have an additional constraint on column 3, which is we know it cannot be 1. So that's going to be 2 or 3. Which means that only the left 2 columns could potentially be height 1, and we're going to determine what that is. So bottom left, and we can just evaluate both possibilities and see what that's going to be, because we just need to find the 1, and then I think this will fall together pretty neatly. So suppose this is 3. If this is 3, the only way that could happen is if this is ice. And then you would have a 2 and a 1 down low, which is potentially possible. Like if this is just a straight 1, 2, 3, 4. That's actually still possible. But I need to think about why this space would have been emptied out. No, we're under a blue block, so you never know. Supposing that this is 1, then. If this is 1, that would mean that this is blue, this is blue. And then this is blue. Okay, so we actually potentially have a bit of a problem here, because if we go with our assumption that the blue blocks just create an ambiguous column underneath, where some of the empty spaces may be filled and some of them may not, then how does it interact with the question block? Because what's stopping this from being 2 and this from being 1? The thing we have to think about is that these are empty. Something had to make them empty. Yeah, because this got emptied out. Remember that, well, we've never had a scenario where an ice block is below a blue block, but we've had no evidence to say that that can actually happen. So something must make this block empty. And it has to be either a blue block above it or an ice block above it. If it's an ice block above it, that's not possible because you create 3 consecutive rows that are all going to be minimum height 2, then you have nothing left for height 1. So we know that's not going to be ice. It could potentially be just P, or just 2. And it could potentially be just nothing. If it is just P, though, we need to determine what eliminated these blocks here. Why is this empty? Why is this empty? So, like I said earlier, because of the bottom left corner, we know one of these has to be the blue block. So supposing so I'm thinking about this and thinking, is it possible for the first column to be 3? If the first column is 3, then that means the top block is blue. And then you just have PPP all the way down. And then is it possible for this one to be 1? Well, something would need to empty it out as well. So it is possible. I don't see the contradiction there. For having 3, 1, 2, 4. But if I find multiple solutions that don't have a contradiction, then we have a problem. So we can try 3, 1, 2, 4. And then that's under this scheme here. Whoop. But we can also try something else. Okay. Oops, let's just go back to what we had previously. And we know it's going to be 4 at the end. So suppose this is not 3. Suppose that you have this instead. And you have 2 up front. And then, is it possible to have either of these be 3? Yes, if this is ice and this is P. And then if this is... Yeah, because if it's under constraint, then we know that there's something wrong with the way that we're reading the blues. I guess let's say this is P. And then we are down to... Yeah, because my notation is kind of conflicting with itself. That's the problem. We might need to sketch this one out in the editor, actually. Because there are enough problems with the way I'm doing it right now that it's going to be an issue. What we're going to do is we're just going to try 3, 1, 2, 4 first. Because I can't find a contradiction in that yet. So let's just be greedy. Let's just go with that pattern. Just to see if it works. If it doesn't work, then we'll just eliminate that quickly. And yeah, we can eliminate that. So there should be a way to formally eliminate it. Because right now, I don't know why that ran into trouble. So we'll put a big no underneath it. Whoops. So I don't know why that ran into trouble. Yeah, there's something we're misunderstanding about the blue blocks then, because we are once again in a situation where I don't have enough constraints. And if we're going to exit out anyway, we should exit out to the editor so we can look at this properly. So Because then we can also retread the level, perhaps, and reread what the blue semantics are. Let's go to the editor, actually. Let's just exit this quickly. And we're going to take it in. Okay, so here's the way I'm thinking about it. Let's close the notes first of all, and we'll try to recreate our progress so far. So this is going to be a 4x4 grid. Oh, whoops, this is not semi-solid. Hang on. This is how you can tell that I don't use this editor mode very often. Let's switch it. Okay, so this is a grid that we're working with here. Let's create some space. And let's copy it over so we have a workspace. We have this layout. Right here. So, this is the layout. Whoops. Under our current interpretation, this is what we know. We know everything is minimum height 1. Let's fill some of this stuff in so we can replace it as we go. So the thing I was getting at earlier, and we'd better get the blue state block ready as well, just to have that ready. Okay. So, the thing I was getting at earlier is that one of these must be 4. It's not possible for this one to be 4 because... Actually, you know what? It might be. We eliminated this possibility too early. That... What if you had this... ice... and then you... Whoops. No, the reason you can't have ice there is because it would create... problems. Okay. So ice would create this around it. And then it would create this. But, and remember that either one of these could still be blue. But what if you had one of these as blue over here? Superplex25, welcome. Let's give you a big shout out to the Jackal Squad. Screw the block trials, yeah, more or less. Yeah, I hope you've been doing well. You can probably get a sense if you played this level at all, or even looked at it, at what we're doing here. So, yeah, so let's say we have this. That would create a minimum 3. That would create a maximum 2. And then we would eliminate all of this stuff to the right. So yeah, that's the one possibility I just hadn't considered earlier because I had immediately assumed that the rightmost column must be the 4. When these two spots here and here could have just been empty in the first place. We should use question blocks to denote that. But I don't think that's possible to be the case because then you run into problems with this. Because you need some way to remove this block. Okay, so in general, here's the logic that we need to apply with the blue blocks. Yeah, so this doesn't work, and I'll show you why it doesn't work. Because whenever you have an empty space that's away at a diagonal, you need some way to clear that space, and the only way to clear that space is to have a blue block on top. So let's maybe just multi-grab something and hang on. Let's just kill this. You basically brute forced it. Yeah, this is my second sitting with it. We ran into trouble last time because I misunderstood the ice semantics, but we managed to progress today, and so we're now on a different part. Let me show you my notes, actually. Some of them. So this is what we have so far. So this is how I'm understanding the rule set. P blocks are definitely filled. Question blocks could be anything. The ice blocks kind of create a cross. So every time you see ice, you actually want to read it like this. It looks like this secretly. Wait, I need to hide my notes. Every time you use ice, it creates this cross. But there's one thing that can cancel that cross, and that is the blue block. Every time you see the blue block, you think of it like some number underneath. You don't know if it's 3, it could be 1, 2, or 3. But any one of those will work. So that's how you do it. So, here's the thing we have to look at. We know that these... So everything has a minimum height of 1. These needed to be deleted by something. Because there's nothing in this space, or this space, we know that it can't be... Yeah, because there's nothing in either of these spaces, we know that it has to be blue blocks on top. Because I can't remember ice can destroy ice. I don't think it can. I don't think we ever saw an instance where ice removed a question block that was creating ice. And actually, I'm still thinking using the old logic of ice removing objects around it rather than creating a cross, which is not the case. And so if these are empty, they cannot be ice, I don't think. Because ice doesn't create ice. Ice only creates a P-cross. So, yeah, that's the way to think about it. I kept thinking about the ice as a bomb element when it's actually creating a cross around it. So, yeah, there was an instance of 2 ice adjacent. I know, we saw it earlier. But you'll notice that in this one, the ice always overlaps it with the question block. That ice never occupies empty space that was adjacent to other ice. The ice only appeared if a question block also appeared. Because ice creates a P-cross around it, but ice can't create additional ice beside itself. Anyway, Superplex, thank you so much for the raid, and yeah, I mean, brute force is brute force, it works, I guess. So congratulations on at least registering the clear. And yeah, Natcat, today's a bit of an overflow stream, given that we didn't finish this previously. You thought of it as question blocks for an irrelevant top layer. Yeah, I heard somebody else who came to my stream interpret that as well, but because it's basically like a mask where you have no idea what's underneath. Where the question block is basically, oh, I don't know what's there. But the question block tells you something very important, which is that something could be there. Whereas empty space has to be interpreted as something can only be there if it was implied by either the blue block or the ice block. I shouldn't say destroyed. I keep saying destroyed, and that actually is the wrong way to think about it. Implied is a better word for it. So these two cannot be implied by ice, because these empty spots do not have ice. These empty spots, in fact, have this. This means that this must be blue. And one of these two must be blue. So, and this one, hang on. Yeah. So this one must be blue, which is why I thought this has a maximum height of 3, this one here. Natcat, I'm not making a puzzle level, I'm solving a puzzle level. This is actually a 7 MMC level. It's number 7 in this week's set, week 4. But we actually had to get into the editor in order to solve it. So anyway, let's get back to figuring this out. So one of these must be blue. And we gotten that far. I had determined that this cannot be ice because it would create 2 columns here. This could be ice because it gets negated by the block next to it. It doesn't have to be, though. That's the thing. I was thinking about the top right as ice, and it definitely doesn't have to be. It could be... It could be anything. Or rather, it could be ice, and it can be the P. If it is the P, it would have ice underneath. Perhaps. But, or not necessarily. It can be anything. So we'll just leave this as is. But there was some reason that I believe that this one must be 4. And I think that was the flaw in the reasoning earlier. That's why I ran into trouble, was that I was assuming that this must be ice when it actually doesn't have to be. So we'll get back to that. We know, however, this is maximum 3. And now we can proceed to solve from there. So now we need to think about, okay, what can remove, or rather occlude these blocks? What can make them empty? Because one of these will have to be height of 1. But anyway, we know this must be blue. At least that's progress. We know it must be. We know this cannot be ice. We know this could potentially be ice. And that even if it is ice, it actually does not matter. It could be completely empty. It could be anything. So we actually don't have enough information to deal with the top right yet, and I forgot to account for the possibility that it is empty. But something must remove these 2 blocks. No, it doesn't, because blue automatically kind of implies emptiness here. So the one we actually need to deal with is this. And again, because of the corner logic we saw earlier, either of these could be blue. Either one of these. So we're actually worse off than we were previously then, because we need to look at this layout again and think about this empty space, because now the empty space isn't giving me sufficient information. So we need to rethink this. But anyway, we know this top bit here is definitely empty. We need some way to designate definitely empty, like I need to use a coin or something. Is it definitely empty? Yes, it is. Because the only way that it could not be empty is if it got implied by a neighboring ice block. But then that actually is possible, because let's take a look at this. Let's copy this over again. We have a couple of different possibilities. Because let's say we have this arrangement where we have ice, and then suddenly we have something like this. And you would think that's a problem because of the 3 columns that have 3 height, but then you do this, and suddenly you're okay. Then you have 2, 3, 2, 4, 3, 1, for instance. And then, whoops, you take this guy out, and suddenly you're okay. You just empty these out. Is there any reason why this shouldn't work? I feel like this does work. I feel like this is absolutely a solution. Where's the contradiction in? We need to think about how this was emptied, though. Ah, no, this is why it doesn't work. No, it does. It totally works. It totally works. Blue always has to start from the top row and then go down. That's a good observation. Does it really? Let's take a look at my notes for some of the earlier blue puzzles, because that's actually a very good observation that I think I missed. That blue has to start on the top. Hang on, let's take a look. Yeah, because actually that's a good point. That in the examples that we were shown, I don't think you have just blue dangling in the middle of nowhere, do we? And actually, even in the one... yes, you do. No. So, no, that's wrong. We had a solution earlier where blue did not start at the top. At least I interpreted it in such a way that blue did not have to start at the top, and my interpretation worked. Maybe I made some kind of mistake. But for this grid, if you remember how it looked... Let me try to illustrate it, perhaps. So earlier we had this grid, and I interpreted it as... let's see if we can... Hang on, I need to show this on camera. Earlier we had this grid, and I interpreted it as something like this. Let's try to construct this from my notes. Have to take a look at this. And then it would be, whoops, something like this. And then like this. Ice, ice, blue, E. We interpreted it like this, and it worked. Yeah, 2, 4, 3, 1. So this was how I read this one earlier. Let's do the semi-solid thing just to give it some extra backing. Yeah, so earlier we used this solution, and you'll notice that the blue was placed not starting from the top just fine. Let me hide my notes so you can see. And in fact, let me move this whole thing over so that's not in the way. But yeah, earlier we had that and it worked just fine. No, this is just hypothesis. This is just hypothesis. I'm not... I'm not committing to this solution. This is just one candidate. I'm trying to figure out why this would not work. Like, is there a reason that this would be disallowed? Is what I'm saying. Is there a reason why this is an illegal move? Because I don't see it. I'm looking at this and trying to figure out some kind of contradiction, because basically this would be... You'd have your question block pattern like this. Where you're assuming that this question block will be nothing. In fact, actually, no, the way to designate this is using an invisible block. That's the best way to designate it. Let's see if we can do it. Okay. It would be like this. Oh, that's so much better. Look at that. So much better. I need to illustrate why the bottom right is empty. Yes. Yes, that's correct. That's correct. That's the missing thing. That's why this doesn't work, then. Because, no, it would work if you have one of these be blue. And any one of these can be blue. Doesn't matter which. So it works perfectly fine, because you still have a match. So you could have something like this, for instance. And that's perfectly fine. I feel like I'm going to try this solution and punch it in just to see what happens. I'll be running through the whole level to do this, but I just don't see the contradiction, and I haven't tried it yet. So we're going to try 2, 4, 3, 1. My worry is that there are other solutions that we haven't attempted yet that will illustrate that I'm missing information about the rules, which is what happened last time. But we're going to turn up notes, and we're going to try a new hypothesis, which is going to be 2, 4, 3, 1. The example with the 3 ice blocks has an extra ice blocks. Pretty sure blue blocks always start from the top row. I'm going to run through the puzzle again and look at that to see if that's actually the case, because Yeah, because this one, for instance, you can assume this. Like, you can also interpret it this way, for instance. But that doesn't explain this one here. Unless this is just nothing. This also could be nothing. No, this can't be nothing. Because if this is ice... Oh, I see, because you can do this. I see. Because you can just do this, right? Yeah, that's true. You could always just do this. Yeah. So this actually is an alternate interpretation that would adhere to the rule of blue always starting out top. Okay, so let's think about this then. Wait, no. Okay, no, there's a reason this doesn't work. Sorry, my illustration is wrong. It has to be this, because the blue has to negate the ice. Otherwise, this would have been filled in. If you don't have blue there, it gets automatically filled in by the ice. So this was actually the interpretation I was looking for previously. Mario floats there silently judging your progress. Yeah, that's what he does. He's wondering why I'm taking so long. So, but then you can always have two blue blocks like this. Okay, because then you just have a continuous column. And then that would adhere to the rule of blue always starting from the ceiling. Right? Like, if you wanted to force this solution to interpret blue as always starting from the ceiling, this is how you would do it. And I think it would work. We already know that this was the correct solution earlier. I'm just trying to contrive a way to make it happen. Because then you have the question block pattern going this. And that worked. You solved them all by assuming blue was always starting from top. Yeah, I feel like that actually is the context that I'm missing, because otherwise you have the disambiguation problem that I've seen previously, where I have multiple solutions that seem to make sense, and they actually don't. But you'll notice that my solution here actually still works. Because, let's say we multi-grab this, copy it over. Suppose that blue always starts from the ceiling. That's easy. You just replace these. And you're done. Right? So I actually had the correct solution anyway, totally independent of blue starting from the top. I don't know if it's correct. We have to go back into the level and try this, because as I said, this is untested, but it looks like a good candidate. As in, I can't see what's wrong with it. I can't see why this would not work. Like, this gets emptied out by something. Yeah, no, it works, because you're thinking, no, you don't need to actually. Why would you need an ice block? Because if you're thinking about the empty space is here, here, here. But they're under blue blocks every time, and if they're under blue blocks, they get emptied out by themselves, right? Like, you don't need to think about ice. So, all of this is we're searching for the solution for a puzzle level that I'll show you in just a moment. We're going to try this out, because I think this is column 2 needs 2 ice blocks to account for the bottom row. Let's take a look at this. Oh, right, because the bottom is empty, right? So, yeah, I'm looking at too many adjacencies here. Let's put this down here so I can actually see the original. Okay, because I couldn't see the original. Okay, yeah, because something needed to take out the bottom. And something needed to take out the bottom in this column. That's correct. That does it. That does it perfectly, in fact. Yeah. Yeah, no, this is design. Yeah, because if you don't have blue in this column, you had nothing to account for eliminating precisely this square right here. Like, you needed to account for this one. So, yeah. Yeah, and Daftlife, thank you for being cautious with not outright spoiling it. I know you're kind of giving me some additional nudges about, like, the constraints that I'm missing, and that's fine. That's an appropriate level of backseating, and I'm glad I'm still stepping through it and doing the work. So, thank you for that. Okay, so for those of you who have just come in, let me show you what this level is and why we have a massive notepad. Yeah, no, don't worry, Daft Life. I think you've been treading relatively cautiously, so... So, this is a level where you just punch in codes by interpreting the blocks to mean different things. And let me show you my notes here. Let me just pause for a moment. Oh, and let me know if sound is working, because sound had actually glitched out earlier, but it seems to be back. Or rather, back when I'm playing the level. So, this is the rule set that we're looking at. We'll add one additional line. Needs to start from top. I think it does. Okay. So basically, we are reading each of the different block types as representing a particular way of reading numbers within this grid. And I'll just let you start the notes there for a moment if you're new to this level, so you can see what I'm doing. So this would be 1, 2, 3. And 1, 2, 3. And we're just getting back to checkpoint, so we can look at things all over again. I'll probably need to redo this if we run into an even harder puzzle later on, but it's okay. That's just a price of admission for attempting things this way. Anyway, I'll take the notes off, and yeah, after a while, as I was saying, you do get a hang of how to visualize this stuff. So yeah, this was the problem I had with the ice at the first 5x5 as well, was that I had an interpretation of the rules that was insufficiently strict, and it worked for every puzzle until the one that got me into trouble, until the most advanced one in the room. Because previously I was interpreting the ice as eliminating any squares around it, rather than forcing the squares around it to be filled. And it led me to a ton of trouble with the 5x5. And here we go. And okay, let's do this one over here. This is 1, 2, 3. Because the question mark is occluding an ice block. Then this one, I need to look at my notes for this one, I think. So we have the order sketched out up above. Yeah. So this is going to be 4, 2, 3, 1. So the line that I'm reading right now is the top line, because we're past checkpoint 1. And then we have 1, 2, 3, 4, 5. But yeah, I think it's reasonable to expect that for this level there is going to be a very wide variance between people who love it and people who can't get through it. As in, not can't get through it because they can't solve it, but like can't get through it because they hate it. Like, I think there's evidence, given my experience with things like escape room puzzles and decoder puzzles in the past, that it's a very specific audience that loves this sort of thing, and I happen to be in that audience. I've had a great time with a lot of cryptic escape rooms on this stream in the past, even though some of them took a lot of time to solve on stream because it would require me to do things like illustrate pixel art in the editor for an hour at a time or something like that. Oh, let's put on notes again. Oh, no, I didn't use notes here because this was an easy room. Yeah, so... nope, wrong. This was wrong. Let's go back. Just punched in the wrong one. And yeah, this one's not my notes, this room, because I just visualized it and didn't have too much trouble. Yeah, because the locks are all hard blocks, once they get broken, they stay broken on the same attempt. And yeah, as you can see, this is an instance So the rule that we didn't notice earlier was that blue always starts on a ceiling. The other thing you'll notice here is that if blue is over the ice is kind of explicitly present. It's never just going to be implied. The only thing that can be implied, in fact, are the P blocks. You can't use the advanced pieces to imply other advanced pieces. Let's say that. That's the rule that we were missing. And so this demonstration here was the really critical one that shows you what the priority is between ice and blue. That blue cancels ice. I mean, yeah, so all of the thing about a level like this is that it's not about the mechanics of how you enter the code. It is solving the code. The mechanics of entering the code do not matter so long as they work. And the switch mechanism to make each of these combinations activate properly is definitely no small feat of design. It's something that does take a lot of work and testing to put together, so a lot of respect for how Rubik's Cube did that. Rubik's Cube being a veteran of a lot of these complex puzzle designs. Anyway, I do need to get my notes out for this room. So we're going to go 1, 2, 3. And Barnstorm, it is much fewer plays, but funny enough, one of the highest like-to-play ratios of this week's levels. Yeah. I mean, I don't know if you're talking about footprints or about attempts. But I think sometimes, you know, people will just stare at this or will see it on the stream and will just register it as a skip, who knows. Anyway, 2, 4 through 1, okay. 1, 2, 3, 4. So it's kind of funny that I actually did propose a working solution for this one without understanding the rule that blue has to flow from the top. Because not understanding that could have gotten me into even more trouble later on, perhaps. But we're going to try the solution that I had because it seems like it's completely workable. It's going to be 1. No, hang on. I'm looking at the wrong part of my notes. Oh, no, I am working off the correct one. Okay, yeah. 2, 3, 4. So the reason I had to do a bit of a double take there is because this is actually the same code entry. So the same mechanism. For this clue and this clue, they have different layouts, but it's actually the same code. And yeah, Barnstorm, that's a good observation that, you know, if you're exiting without having cleared the level or timed out on it even once, like if you're not even going to bother to try it, then you're not going to have the ability to boo it. So you'd have to be pretty mean-spirited about explicitly booing it. We're going to time out before we get a proper look at this. Let's just screenshot it anyway in case we need to go to the editor. I think we'll probably want to go to the editor for these ones, which means I'll have to retrace the whole puzzle, but that's okay, it's quick. But let's jot it down in my notes anyway, perhaps. Just so I have a quick visual reference without having to duck in and out of my screenshot library. Okay, so that's one puzzle. And then the next one after that, I'd like to solve this first one so we can scroll further on the screen and see what is in the next set, because we're not at the last scroll stop here yet. So let me see about this. Okay. Kind of occluding my own screen here. So that's the layout that we have. Let's try to do the first one on paper. The reason I say that is because I want to reveal more of this room, so we don't have to restart this level so many times. Once again, the critical locations that we should always be looking at are the ones that are so far removed as corners that there are a limited number of ways that they can actually be obstructed. So it would be this square here, well, the rightmost one, if I can, yeah, the rightmost one here, and bottom left one here. Drabishad Visitor, you just declared the puzzle to be trivial at the circle when you said, yeah, all of them are ice blocks, because you thought they might behave a bit like bombs. So Yeah, like I was saying, I thought they were bombs until I hit a puzzle late enough that negated my theory. So it's one of those things where you can just happily solve many of these layouts with an incomplete picture of what the rules are, and then you suddenly discover that your interpretation was insufficiently strict. And I mean, given that each successive puzzle is kind of adding information about rule collisions and how to evaluate these things, perhaps that's fair game in a way, but it definitely kind of caught me off guard because there are moments when you have to retread through the puzzle and sort of understand that the rules weren't necessarily what you thought they were, even though you had already solved a couple of puzzles with your previous theory. So it's kind of like Newtonian mechanics or something, right? Like they get you pretty far up to a point, and then suddenly you realize you need relativity. If that analogy works whatsoever. Okay, so let's try to solve the first one on paper here. The reason for that being, once again, that I want to make a guess at it quickly and then see if we can reveal more of the screen. So, and we'll leave some ample space before we get to the next one, just so we can look at this properly. So, once again, we're dealing with the bottom left corner and the top right corner. And that's going to give me... let's shrink the notes a little bit again so you can see. That's going to give me something to work with here. Because you know that the right one cannot be 4. You know right away that's going to be 1, 2, or 3. You also know... So under what circumstances can this one be 4? It can't. This column can't be 4 because if it is 4, the P block on top of column 3 would have to be created by an ice block, which would then create 2 columns that are 4. So this one is also 1, 2, 3. And that means that of the first 2 columns that have the question blocks on top, one of them is going to have a height of 4, and the other one will not. Now, we know from the bottom corner here that there must be a blue block in the leftmost column. And we know that blue blocks flow from the top. So then this way, we also know this is 1, 2, 3. That means second space is definitely going to be 4. So let's sketch out what we have so far. You know this has to be blue. And that this has to be just P. And then we'll see what happens from that point on, because now we have something that looks like this. So we have B and P up top, which is why we know this is 4. This is going to be maximum 3. Now, in order for this to be 2, this would also have to be blue. This one here. And that's the only way to impose 2. And in order for this one here to be 3, I hope this is large enough for you folks to see. Let's do this. In order for this to be 3, because I don't know if any of you are on mobile or something, let's think about this spot here. Under what circumstance can this be 3? This would have to be ice, and that's possible. That's entirely possible. Under what circumstance can this be 3? Well, for that to be 3, this one might be ice. This one might be ice. But you'd have to pick one. But it's possible for that to be 3. So we need to constrain this further. Now, because we know that this is a 4 column, we can fill this out right away because these are empties. This is empty. This is empty. Therefore, we know that there has to be ice in some of these locations. We know, for instance, that this must be ice. That means this one here is minimum 2. So we can eliminate that. We know that this can't be ice because if it were, it would create another column of 2, unless this is a blue block. So it's possible for this. Actually, no, it has to be because if this is ice, then this can be blue on the left, but you would still create a 3 column over here. So we basically have 2 theories that we need to deal with here, which is either this is ice or this is P. We're going to try both. Okay. So yeah, we know this is P, we know this is P. We know this is ice, we know P. We don't know what this is yet, but we have 2 theories. Either this is P, or this is ice, and we'll just follow both branches. If this is ice, this gives you P. If this is P, we still don't know what this is. If this is P, however, this gives you blank in this location. This forces this to be 2. And this would definitely be forced to be 1. Under these circumstances, this could still be ice. And then you could potentially have this. So how do we eliminate either one of these interpretations, given that blue can go pretty low? And blue can pretty much eliminate anything under it, right? Actually, maybe there's something else I'm misreading about the blue, which is that in the segments where blue earlier was placed over something incomplete, maybe we had to do that. Axter Typo, let's give you a quick shout out. Axter Typo coming in with the Scrabble crew. I hope the tournament schedule has been good to you lately. So we may be theoretically playing Mario Maker, but this is actually a pure mathematical and geometric puzzle. So those of you coming from Scrabble, I think, are going to get a kick out of it. Yeah. Chess Bunzo, you want me to read number 1? Yeah, since you're coming in, we'll just do that really quickly. Once I turn off my notes screen, we'll just do that reward redemption, and then we'll see if we can solve this with the 30 seconds remaining on the clock. Let me just bring up the text because I do not have this by memory. Yeah, blue hides P blocks in this column. Exactly, definitely. I thought it was the case that blue is kind of a maximum upper bound. And I thought that was pretty clearly illustrated by the samples that we saw earlier on. Anyway, William Shakespeare, sonnet number 1. From fairest creatures we desire increase, that thereby beauty's rose might never die. But as the riper should by time decease, his tender air might bear his memory. But thou, contracted to thine own bright eyes, feedst thy light's flame with self-substantial fuel, making a famine where abundance lies, thyself thy foe, to thy sweet self too cruel. Thou that art now the world's fresh ornament, and only herald to the gaudy spring, within thine own bud bury'st thy content, and, tender churl, makest waste in niggarding. Pity the world, or else this glutton be, to eat the world's due, by the grave and thee. Thank you for that, Chess Bunzo. Anyway, let's bring the notes up. Astro Typo, the bedtime story you didn't know you needed. Well, now you know it. Okay, so I'm going to illustrate this for newcomers in just a moment, but basically we're doing a series of constraint satisfaction puzzles where there are different types of blocks that are in every grid layout, and they impose a certain key entry order. So if you look at this one, you got a 4x4 grid, and each of the columns, once you resolve a certain set of rules, would be uniquely assigned to the numbers 1, 2, 3, and 4. And you need to figure out that order and then punch that into the blue skulls that you see here as a kind of a combination code entry. And that's how you progress through this level. And the entire thing is like this. So the entire thing is no Mario expertise required. All of it is purely just solving these little logic box layouts. And we've gotten pretty far so far. But I'm trying to work some things out on paper right now because we have to test out a particular theory before I run out the clock in this particular instance, although we're not too far. Actually, no, we'll run out the clock. Because then I can show you what this looks like, maybe. Although the previous segment was already kind of getting into some of the theoretical territory. Anyway, yeah, have a good night, Astro Typo. Hope the stream, once again, was excellent to you. Okay. Actually, this is a bad place to start showing you this, because we're already at the point where it's all question blocks. I don't know how Theory 2 could make sense. Yeah, I have to go back to look at that, because once again, I lost track of what I was doing. Yeah, this is the segment we're looking at. But anyway, let's do the code entry first of all, and I'll just show you. So they basically all represent numbers. So you get 1, 2, 3. Then... yeah, I'll have to... This segment of the level doesn't actually show you how the rule set works, so... I may have to restart anyway if people need an explanation, but... we'll do that when we actually have a reason to go back to the editor to do the layout. And so, if you have no idea what's going on and just came into the stream, bear with me. We'll explain it with time. So anyway, we're back to this grid. And so what happens is that there are a couple of different block types. Right now, all you're seeing on the board are the question blocks. The question blocks could be anything. They're basically wildcards. They could be empty spaces. They could be one of the other blocks. Then you have the P blocks, which are spaces that are definitely filled and count towards the number that you're looking for. And then you have the blue blocks, which are kind of this waterfall from the ceiling that create a negative space. And you have the ice blocks, which create a cross pattern. And you basically have to figure out from the information you're given what kind of layout could be occluded by the question mark blocks that you see on the screen in order to create a constraint satisfaction solution that gives you, in this case, the numbers 1, 2, 3, 4 on the 4x4 grid. So we're testing out a couple of different theories right now, and yeah, so I'm looking at this conjecture here. The second one here, which is this a P or is this ice? Because if this is ice, then you would be looking at something like this, right? Where you could have blue block in this location, and then you would have, this would be 1, 4, 3, 2. Whoops, sorry, 1, 4, 3, 2. Under this theory, you'd be looking at something a little bit different. You'd have basically 3, 4, 2, 1. And we need to eliminate one of these, because this is entirely possible. Yeah, so you see the error, right? I'm looking for the error right now, because this one of these has a contradiction. One of these has a contradiction. And we need to think about whether we have sufficient information to eliminate the empty spaces, or if we're eliminating them at all. Under this scheme, perhaps we're not doing it. So let's say we have blue over here. And then we can fill this out. And then we need to eliminate this square, and we need to eliminate this square. I see it. In order to eliminate this square, we need either this or this to be ice. And that's the problem. One of these two must be ice in order to create this hole. And if one of these is ice, then you create a problem. So for example, let's say this is ice, then suddenly you have 3 up here, and suddenly you have 2 here. And so I think we're in the same situation that we had earlier, where like one of these two could be ice, and it would still work either way. And you know that you can't have both of these be heat. But what's stopping you from using this as blue? Oh, because there's no ceiling above it. Yeah. Yeah, so the fact that blue has to flow from the ceiling is important here, because otherwise you could designate this blue. So if I didn't know that, we would have maybe fallen into a bit of a trap there. But you can basically empty this one out. And this can be empty. And then this gives you 1, 4, 3, 2 as before. So it doesn't matter, I think, if this is the ice or if it's a P. It actually works either way, I think. It does matter, because this location no, it doesn't matter. It doesn't matter, because this block is taken out by this block either way, right? So no matter what, you wind up with the same conclusion, even though it's slightly under constraint, and there's actually a little bit of ambiguity as to what this block is going to be. But it should not matter whether this is P or ice. If this is P, it actually gives you the flexibility to have this also be a blank. But again, the ambiguity doesn't matter, because we have the same solution either way. 1, 4, 3, 2. Let's try it. 1, 2, 3, 4. It's wrong. Okay. We have a bug. Oh, wait. My notation is completely wrong. I had a 2 in... Yeah, no, I had a 2 in this scheme. So I just lost track of my notes. But then... Ah, yes, I see. I see. Then we have this. This could work. Columns of blue blocks cannot have blanks. Really? We need to go back and look at that rule then, because I was wondering about that, because I thought the idea was that the blue blocks were just an upper bound. Although maybe in those circumstances I was just missing some kind of ice block clearance that was going on. And then this would give you 2, 4, 3, 1. Let me just inspect this carefully to make sure it works. I need someone to designate like what's been eliminated from the empty space. But this is the only one that we definitely need to eliminate, so we need ice either here or here. It's not going to be here in this case. I think this works. But then we need to be absolutely clear about why the first solution was bugged. Yeah, so that's correct. 2, 4, 3, 1. Again, I kind of suspect, given the number of 2, 4, 3, 1s that we have, that Rubik's Cube has a particular lock design based on 4 skull platforms that he reused because it was mechanically consistent. I kind of get the sense that, you know, he's using obviously the same lock mechanism. It's not the only lock mechanism with the 4 code entry. We previously saw something a little different. 4231 instead of 2431, which just requires a little bit of a reordering. But I suspect that there are probably some reasons to do with the lock mechanism that we only have so many combinations to work with that are strictly enforced. I don't know. I'd have to look at the mechanism itself, possibly in the level viewer tool or something. The lock design is incredibly easy and the code won't matter to that. Yeah. Yeah, because if you're just pushing objects around with these skulls, then it should be okay. So I think it's just a coincidence then. Anyway, so let's take a look at this. I need to understand why the first one is bugged, and we're going to say no to this one and yes to this one. And it would be... I see. Because in order for this to be blanked, I think there's something that we missed about the way that the earlier blue setups were done then, because I thought they could be just a greater than. But maybe that was only in circumstances where you had ice on the side, eliminating this. And we know this can't be ice because this is an empty space here, which can only be filled by P if it is filled by anything at all. So that's another flaw in how I understood this. That let's hypothesize space must be filled below unless implied by ice? Question mark, because I'm not really sure. And I'd have to go back over to previous examples to confirm that. But I'm not going to do that right now because I want to, once again, scroll further and make sure we have this under control. Okay. So let me just fill in the last one of my notes. Yeah, because I just want to make sure that we see all of the screen in case we need to get back out to take a screenshot and redo the level. Just by virtue of punching things into the editor. So these are the two puzzles that we have next. We have column 1, 2, 3, 4. And we'll copy that over as well. Okay. Maybe we're fine then. Let's take a look at this. For illustrative purposes, since we're at the end of this segment, maybe I should just skip into the editor view now. But again, the clue that we're going to start with is the isolated corner. Because the isolated corner is the thing that is going to create, well, it's going to give us a fair bit of information to work with. You know what? I want to look over that blue clue anyway. So we might want to restart. But let's see if we can progress. So because of that isolated corner, we know that there has to be blue in this column. And because of this spot here being empty, we know that at most that can be a P, it can't be an ice. So this would be minimum 2. And because there has to be something blue on top, it's maximum 3. So column 4 is going to be 2 or 3. Blue's clues, exactly. That's what it is. So one of these has to be blue. Now, this isolated question block is kind of interesting. Because this isolated question block, it cannot be P, because if it is P, this would have to be P because the column is continuous. And this would have to be eliminated by ice around it. So this spot here, so this is either empty or it's also blue, perhaps. Yeah. It cannot be filled. It cannot be filled by ice. It cannot be filled by P. So this is maximum 3. So column 1 is going to be 1, 2, 3, so far as we know. Column 2. So now we think about what's at the bottom here. We know that the bottom spaces must always be filled by something. And that... You know what? Let's do this in the editor. I don't mind going through this again. Let's do it in the editor. If we're doing it in the editor, maybe I should go back to the blue clue quickly, just so we can confirm that the rule is what we think it is. Let me just... It is appropriately sized, first of all. Okay, so, for those of you who have not seen this before, this is how it works. Columns 1, 2, 3. Very simple. It tells you the number. Columns 1, 2, 3. And that's fine. Then you get to the ice. Or, no, then you get to question blocks. Question blocks are wildcards. They can be anything. They could be blank, they could be blocks. So you punch them in, and you are fine. And then the middle block here enforces that this must be 2. Since it must be 2, you take a look at the empty space in the top corner. And that gives you everything you need to know. Now, I'm just getting back to the blue segment here because I need to take a look before we get into the editor to start testing things. And we'll need to do that. Okay. Yeah, this stuff is pretty easy to visualize. And then we'll just go back here. And we'll do this. So here's the ice block. The ice block creates a cross. That's the way to read it. It generates a cross. Then you have 1, 2, 3. And then 1, 2, 3. Okay. Now let's get this done quickly. We'll have to repeat this a couple times, of course, because I'm stepping back into the editor afterwards. 1, 2, 3. 1, 2, 3. And this was all previously solved. And as you go, it gives you more and more information about how to read the various constraints. Then it's going to be 1, 2, 3, 4, 5. So we need to read the blue semantics again because we have been missing something about it. Okay, so first of all, blue always comes from the ceiling. Now, why was I reading this as a less than function? This strictly constrains it, this one here, so I'm not too worried about that. Like blue, you just think about all of the empty space under it as a P. But why not here? No, this is fine. This is still 1, 2, 3. We still haven't seen the interaction that I'm looking for, which is... Let's see here. Here it is. This one here. So, if you look at it, blue can be 2. In fact, this has to be 1. This has to be 2. This has to be 3. Oh no, so that still doesn't give you enough information, actually. Because I'm wondering basically if there can be blank space under the blue, because I don't know why I got that impression. There was one particular segment that convinced me that you could. And we need to get back then to our previous solutions to see what we did wrong then. with that, because yeah, maybe I just made a faulty assumption about that. So let's get to the editor then, because given the information we have about blue, it's true. We don't have a reason to believe that there can ever be an empty space rather than just a continuous P column underneath. So I don't know why I thought that was the case, but let's fill in the designs that we're looking at for ease of explication. So, okay. First one here. And we'll solve them both before we go on. So we don't need to repeat all of this stuff. So, here's the first puzzle that we're looking at. It's going to be this layout. And I love that I came up with using the invisible block for question blocks that disappear on us, because that's actually very, very useful. Whoops. Okay, so this is the design of the current puzzle. Whoops, multi-grab, please. Okay, so this is what we're looking at. We know that every row has minimum 1. I need some way to designate the spaces that must be emptied out. I wonder if I just use bomb for that, maybe, actually. That's... no, because you're going to have so many conflicts with the blocks. Yeah, no, let's not make this too complicated. So, we know that because of this piece, something needs to remove this piece from the board. There's no adjacency here, no adjacency here. This means that one of these two must be blue. Not necessarily both, but one of these two. Because minimum one of these two is blue, you can fill this in. Because if this is blue, it implies this is also blue, because blue always flows from the top. So, it could be this, it could be this, but we know this is blue. That's the important thing. Next, we're going to look at this corner piece over here, because this is really important. This piece over here, if it is filled, then that would imply blue over here. If it is empty, then this would be empty. Because there's nothing to destroy it here, nothing to destroy it here. This can't be ice. Not destroyed, nothing to imply it here, nothing to imply it here. This can't be ice because it would imply this, and then you would have two spots that are columns of height 4. So this could be blue and it could be nothing. We don't know yet. And either way, we know that therefore this is less than 4. This is why in our notes earlier, for this puzzle we said 1, 2, 3 and 2 and 3. Given these constraints, we know that 4 must be one of these two in the middle. And we'll need to test out that theory. We'll actually just try them both, because we have a good series of constraints to work with here. So let's copy this over and give ourselves 2 branches to work with. So let's designate this. We're going to do one that supposes this is 4 high. And we'll do one that supposes this one is 4 high. This is not a good way to designate this. I'm not giving myself enough space. So suppose this one is 4 high. How could that work? It could only work if this was implied by something else. Nope, that's not going to work. Because there is nothing that's implying this block, because once again, this corner structure here. So this corner structure, this kind of L shape, is the critical thing that we're looking at in this puzzle. Because whenever you have this kind of diagonal, or this kind of diagonal, it actually severely limits what can interact with that block. By that logic, we know, actually, that this must almost certainly be the 4. I'm pondering this for a moment to see if this works. Because, yeah, this can't be 4 because this can't be ice. This can be 4 only if this is ice, but then we have a problem. Which is, what do we do about this slot here? Nothing, because this slot is implied by ice just fine. So we have a 4 column, we have a 3 column. This means that this must be either 1 or 2. And because this is ice... No, we know that this is 2 or 3, so this is 2. We've got this. This is a way better way of illustrating it, actually. I'm glad we popped out here. So, that means this is nothing. And then you have P and P and P. That gives you 1, 3, 4, 2. We're going to punch that in. That's going to be my theory. And actually, I'm pretty satisfied with that one. 1, 3, 4, 2. Let's put it into sequence. We'll put a question mark next to it because that's yet untested. Then we'll go to the next puzzle, which is this one here. Okay, this one actually sorted itself really quickly once I punched it in the editor, assuming that I'm correct. But we've developed a better sense of the constraints as we go, and the more we understand the blue blocks, the better off we are. Let's illustrate this one first of all. Okay, so what do we got for this one? We have this, 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 this. Yeah, again, we're looking at corners, like this kind of structure, this kind of structure, because they create the strongest constraints. So we're going to start with the original template here, and then let's just play with it. And we're also at the goal, as you can see. We've got to extend this eventually, but we'll take care of this now. Since there's no secret room yet, I'm sure there's going to be some mega bonus puzzle at the end that we'll need to be extra vigilant about. And we'll take our time with it. So, this is fine. This is fine. What we have here so far is we know that this will be empty because nothing can interact with it. So we know that this will not be 4. And then we can jot that in our notes. Once we get down to the appropriate puzzle, that this one we've constrained down to 1, 2, 3. Squeeze my typeface down just slightly. Okay, and we'll do it like this, so the screen is nice and visible. Okay. So now we should deal with what's next to it. Now we should deal with the other corner piece down here. Once again, we know that these are always filled, at least. And we know that if they're empty space, they can only be filled by P. Which means they would have had to be eliminated by something. There are no spaces up here, which means that this can't be blue because blue must flow from the ceiling. Therefore, we know that one of these two must be ice. Could be this one, could be this one. And we'll try both just to see what happens. We need to extend some space. Hang on. Okay, there we are. Okay. Let's try both branches. So, there's one branch where this is ice, and one branch where this is ice. Actually, let's... So we can maintain some separation between what is confirmed and what is not confirmed. Let's do this. So, currently we're figuring out the removal of these blocks down below, and specifically this block. So it's not blue here. This block needs to be removed by something. Either this is ice, or this is ice. Could potentially be both, but let's follow these to their logical conclusion. In the event that this is ice, you suddenly have this. And because you know that this can't be 4, this one would have to be 4. And then that would make this one 1. But then you would need to make sure that all of the empty spaces are accounted for. And I think they are. Because basically you would have this be nothing, and this be 1. That gives you 1, 2, 3, 4. That actually works perfectly well, I think. So the empty spaces that we need to account for, this needed to be destroyed, or rather implied. We have a problem here. We don't have anything implying this spot right now. This one right here. Yeah, because as before, we need to look at the corner location. The corner location is the most important thing. So we need something to imply this spot. The only thing that can do it is either a blue block above, which would then make this column 3. Either you have a blue block above, which would then make it impossible for anything to reach 4, or you have an ice block beside it, which would make it impossible for anything to be 1, I think. Unless... let's try this. Yeah, because then you have nothing that's going to reach top. So yeah, this we can eliminate this one. This one just does not work. So let's test this one now. Okay. This one here should work. Because it gives you 2 on this end. And again, we need to do something to imply this piece. Could be blue. If it's blue, then... oh, once again, you get into a situation where this has to be ice, right? I'm still forgetting that whenever you have blue blocks above, that they kind of create this continuous cascade. So suppose we go with this instead. Ice, which then creates this. So then how can anything reach 4? We're still having some issues determining that. Well, this could be 4 if this is ice. I think we messed this up. We need to think about this one a little further. Okay, because suppose this is ice. No. That would be fine because that would imply a bunch of stuff at once. The problem, once again, yeah, actually that does work. Because you would basically have something like this. These spaces got emptied out because there is something blue above, which is minimum this. Then is it possible for this to be a continuous cascade? Yes, it is. Because then you have something that looks like this. But then this being a corner, does this get eliminated by anything? Currently it doesn't. But there's an easy fix for that, which is to put ice over here. So let's see if there are any problems with this interpretation. We need to make sure that all of the blank spots are properly eliminated. This is the main thing that we're looking for. So we're looking for the blank spots. And we need to make sure that their emptiness is accounted for. That's true of all of these. And that's true of this one as well. The problem is that we have nothing of height 1. That's the current issue, that we have 4, 3... We have 4, 3, 3, 2. And that's a problem. That doesn't work. So this is not a valid solution because we don't have a 1. What if this is not... But if this is eliminating this block, this doesn't need to be 4. We're still going to run into problems with not having a 1 unless we punch something like this in here. In which case, we can do this instead. That suppose we have just something like this. Yeah, then you don't need a blue block because this eliminates these two. This eliminates all this. Not eliminates. I keep thinking of this as a deletion. It implies the P, rather. It implies the P. We need to do something about this top corner. We can always just remove it. We're still running into a problem now, though. We still don't have a 1. We don't have a way to get a 1. Yeah. So I definitely feel like we lost track of how we managed to get to this configuration. But suppose this is not ice at all. That's fine, because this still has something to eliminate it. This works now. And this works perfectly fine, I think. Because you have, yeah, nothing here down to, well, no, because ice is going to create something here. No, that's fine, because this is 2, this is 1. I think now this works. This is going to be empty. These 2 are taken out by this ice block. These 3 are taken out by this one. This gets filled in because they were question blocks to begin with, so the question block pattern still makes sense. And then this is the kind of pièce de résistance here, that this piece actually doesn't matter. This piece could be anything. It could be ice, it could be regular, but regardless, we're going to go 2, 4, 3, 1. Again. So, let's get the notepad out. And that's going to be the working theory here, is 2, 4, 3, 1. And we'll go 2, 4, 3, 1. Another one. Question mark next to it until it's been tested. Alright, let's redo the level, and we'll have to redo it again after that, depending on what's in the next room. Okay, bear with me here as we get back to where we were. After I get the solution, I'll be very interested to see other people's note-taking strategies. Obviously, it introduces a little bit of inefficiency to redo this every time, but I do feel as though the method of taking this into the editor was substantially more efficient. It does mean that the best way to actually play this level, since you can't just exit past checkpoints, preserve the checkpoint, and go back into a level while switching to the editor in Mario Maker, is if you have 2 switches running 2 copies of Mario Maker. Most people use some kind of drawing software. I feel like this method is better in some ways. I feel like it's much more efficient, even though it doesn't give you a good picture of branching possibilities where you need to account for 2 different possibilities, like you would in, say, a Sudoku graph, where you know how people who do Sudoku tables usually just notate in the corner what the possibilities are, and they try to use that to track different pathways. I'd imagine that if you're using drawing software, you do something similar, where you notate in the corner, and you would just kind of imply branches that way. I feel like this way, though, it's abundantly clear which Mario Maker elements I'm working with, and yeah, the advantage is that I don't have to redo it, but this is quick enough that I don't care. And the thing is that I found that the things that I have been stuck on have all involved misinterpreting clues earlier in the level and getting away with it for many, many puzzles, right? So it actually is worthwhile to retread through the level and get a new look at the earlier clues to understand how I might have misunderstood them. Because, you see, looking at this again, for instance, I don't know why I got the impression... Whoops. I don't know why I got the impression that the blue blocks were merely an upper bound that could have empty space underneath. I thought it was true for some reason, and I actually don't know why now. And so if I just instinctively misread something like that, I do need to revisit the puzzle to actually reconsider that. Now, like I was saying, since there does appear to be even more puzzling up ahead of us, we will need to redo this again, but it's okay. I've got things notated. You have to wonder how tightly optimized the speedrun time is on this, by the way. That's a lot of code entry to do quickly. Anyway. Yeah, because you basically have to be perfect around your corners for 3 minutes on end. That's why we don't do the speedruns. Anyway, let's take a look at this one again. This is going to be one. You use pen and paper and switch to drawing software once you got to later puzzles. Yeah, like I was saying, like it seems like the optimal method for this is to have 2 switches open with 2 copies of Mario Maker. Or, oh, you know, I mean, I guess I'm streaming, so I'm a little additionally constrained because I'm streaming and I do need to show what I'm doing on the display. If I were not, you know what the actual approach would be? Is to get out my Wii U and to do the diagrams in Mario Maker 1 using the Wii U tablet. That would actually be the method. Anyway. And man, if you get out your 3DS, you could probably do it on this 3DS as well, and it would be less clunky. Oh, there are no blue blocks, of course, in... Actually, there are no P blocks either, are there? So you'd need to use substitutes for that. And so it wouldn't be as clean looking as what we have here in Mario Maker 1. But good enough for our purposes. As far as my note-taking is concerned, the thing I'm proudest of, as I was saying earlier, is using the invisible block for question marks that designate nothing. I feel like that was a stroke of genius, if I may say so myself. Okay, here is the moment of truth. This one we solved earlier, and now we're going to enter 1, 2, 3, 4. And here we have another 2, 4, 3, 1. 1, 2, 3, 4. Okay, looking at the coin count. Whoa. Whoa. Hang on. This is a long way to go to not have the correct solution, given that I didn't replicate it in my notes. Well, we're in trouble. So this was the one where I thought that it was the blue block on the right side. Okay, let's try to recreate this from memory. I should have jotted this down in my notes, or screenshot it. But I was so confident in this being the right solution that I didn't think about it. So why did I think this was 2, 4, 3, 1? So what was the solution that we had earlier for this? We had nothing, and then we had P. And then we had P, And then we had ice, blue, P, and P, or ice. Why does this not work? Because I see it immediately. This spot here. No, we had ice down here. Because this creates P. This creates P. No, wait, then why doesn't this work? Because this is how I got 2, 4, 3, 1. Oh, I know the error here. Because I put in blue block here, once again forgetting that blue has to have blue above it the whole time. That's the mistake. That's the mistake. Well, we can go back to the editor or we can try to fix it here. We may need to go back to the editor because this is complicated enough that it might be a problem. Suppose we have P over here. Yeah, no, that's the rule I forgot. We just forgot to apply that constraint at the very end and I didn't check it. Currently, the biggest issue that we have is forcing one of these to be 1. It's very difficult to actually make one of these represent 1. We need to think about this. Why did I not consider that this column here could be 1? Because we're running into all kinds of trouble. Let's see here. Yeah, because let's say this is blue. Then we have P, P, such. Let's try to do this as 1 and see what happens. And this would be a blank question block. This would be ice down here. Is there a reason this wouldn't work? Let's take a look at the layout once again. We'll check all the blank spaces. Let's zoom in so we can take a look here. Is there a reason this doesn't work? Blue takes care of all this stuff. Ice can be in the bottom corner because there is a question block there designating that. And that would account for this spot. This currently is a problem. We don't have something to eliminate this. So now that's the constraint that we're running into. That this block doesn't have something implying it. It must be implied by either this or this. We may need to go back to the editor to see that properly. There could also be a blue block above it, but then we are starting to run into trouble with not having an option for something that can fill out a column of 4. Currently, I feel like the only column of 4 that we can have is the second digit. Because you have this little corner piece here, once again, that you run into trouble with if you do not designate this as blue, or if you do not designate this as... Like, if you insist that this is filled out all the way, this is a problem. Unless there's ice in the bottom. Okay, there is ice in the bottom, so... You have ice, this... What if this is ice? And then what if this is blue? Then this would be P. This would be P that's vacated by the ice down here. Then so you have 4, then you have 2. And then you have ice, Whoops. What was this? Okay, and then that gives you 4, 2, 3. Nope, this is the same thing that we ran into earlier, was that we are not accounting for the fact that this piece gets you into trouble. We can't find the 1. That's the main issue that we're running into consistently. However, if this is blue and blue, this can't be blank. This can't be just nothing, because we have ice here that is necessary in order to... You know what? This is not necessary. What are we doing? We can in fact do ice over here, E over here. This needs to remain ice because of this mod. So now let's inspect this one. Let's trace the question block path first of all, to make sure there's nothing outlying it. So all the ice blocks are in valid places. Now let's check the constraints. Ice blanks out these 2 spots, great. BB gives you a 2. No, because currently we have a 4, 2, 2. We need a 1 somewhere. That's still a massive pain. We just haven't created a 1. And that's the thing that we need to start with. I think we need to figure out under what circumstances can one of these be a 1. It's entirely possible. We need to get back to the editor, and we need to redo this because this one is a mess right now. So let's redo it. We've been on this for ages. Let's go back to the course maker. Let's figure out what we did wrong. So this is somehow wrong, and the reason it's wrong is because we didn't have a way to create this blue block. So what do we do about that? Well, let's get this out of the way first of all, because it's wrong. We'll put it aside as a visual reference so I know I'm working with. Let's just try to reason again. So once again, we know the bottom row has some things filling it. We need to somehow create something that would be designated as 1. And we need to theorize each of these, I think. So let's just try it. So suppose that first one is 1. That this is nothing. Then suppose that we just have blue to give you 3 or yeah, because the thing is blue would fill in this column just fine. We don't know about this block yet, so let's just put this in for now. Because this could be 2, this could be 3. Do we then have a way to empty out these spaces? Yes, if it's blue, that's fine. This is all taken care of. But then how do we get something to reach 4? That's the other issue that we were running into, is that we don't have a way to get 4. Under this scheme, we can't get 4. However, what if you did have 4? What if you had this? And what if you had this? What if you just had a 4 column that goes this way? Then you would need to remove these 2 pieces. We can't really do that. Unless if ice over here and ice over here. That runs into the same problem that we had previously, which is that we don't have a 1. Unless say we do this. Let's try to do this. What does that do? Nope, we can't do that because ice creates a spot over here, which we can't eliminate. So we're still in a lot of trouble, actually. Yeah, we need to rethink this one from scratch because there's something that I'm definitely missing here. But anyway, we need to think about how these 2 blocks get removed. Once again, because we know there's no blue up here, this must be ice or this must be ice. This was how we were doing it earlier, and we had eliminated one of these possibilities. We knew that if this was ice, then you would have something like this, which is perfectly fine. This, remember, could also be ice. Potentially. Maybe that's something that we hadn't considered, was if these are both ice. But again, we still have tons of trouble getting the 1 to happen. Unless ice yeah, we need to force the 1. That's really the short of it. And we need to do it systematically. We already considered what if the first one is the 1 column. Now we need to consider what if the second one is the 1 column. Actually, no, let's start from the right. No, let's do it systematically. What if the second one is the 1 column? We need to eliminate this possibility. I would create either this or this plus this. No, it wouldn't, because ice would create problems here. So, nope, it has to be this. This is the 1 column. If this is 1 column, what's the 4 column? Can't be this because we have, again, no way of eliminating these locations. And then suddenly we just don't have a way to get 4. So, we can eliminate this. Yeah, I feel like the 4 has to be on the left half and the 1 has to be on the right half, and that should have been enough information to work with. So, now let's take a look at column 3. How do we make column 3 represent 1? Well, we can do this. We can't do blue because blue has to be continuous. And then we need some way for this spot to be eliminated, which means ice over here and E over here. So you've got a 1 and a 2. Great, now we need to do 3 and 4. So if we do 3, this is still a problem. Because now we don't have a way to eliminate... So right now we're assuming that this is going to be 1. Because we're trying to test that theory. I feel like that's going to lead to a contradiction because this would force this to be 2. This over here, neither of these can be 4, I think. If this is 4, the way to do it would be... Actually, no, you can do it. You can do it. Because, remember, blue can cancel this. Isn't this what we came up with earlier? No, it's not. It's actually slightly different. But then you're running into trouble again, because... Yeah, no, blue is fine, because blue will just send a cascade. And so we have 4, 3, 1, 2, and that should be correct. So let's jot this down, because I think this is good. Why don't we just do it that way to begin with? Yeah, we should have noticed it. We should have noticed from the start that 1 is the hardest thing to do here, and we just needed to iterate over 1, and that would have given me the solution really quickly. Because it's doing the 1 that was the hard part. So, anyway, let's redo the whole level once again. And, yeah, so this was confirmed, and then this one is 4, 3, 1, 2. I should have screenshot that or something. Let's take one quick look, just we confirm that this is what I had. Yeah, 4, 3, 1, 2, so this is the layout I had. Let's go over it very, very quickly, just to be sure. So, as far as question blocks go, we have this, 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 and this. That's all valid. There's nothing outside of those that we need to deal with. Now we need to deal with the empty spaces. Okay, this eliminated by ice. This eliminated by ice. This eliminated by blue. Same with this one, in fact. And okay. And then these 2 locations here, both taken out by ice. I think this is correct. It looks like it suddenly clicked into place, so we'll do it that way. And let's go. Anyway, let's redo it. Yeah, when you're doing puzzles like this on stream, there are basically 2 limitations. First, that you do have to present things in a way that's readable to the viewer. There are only so many ways to do that, especially with more complex puzzles, like some of the escape rooms we've done in the past that required literally drawing pixel art in the editor for some amount of time. And the other constraint, of course, is that I can't just, you know, shut this off and walk away at random intervals, in spite of the fact that when it comes to puzzle solving, that's actually one of the most powerful tools in your toolkit, as I discovered in games like Baba Is You, and many other puzzle games besides, and indeed in this puzzle when I walked away from it for literally 5 minutes when we bailed on it the other day. That very often the best thing that you can do for yourself in the course of solving a puzzle is just to walk away and clear your head, and, you know, as soon as you think you're done for the day, suddenly you see it. That's exactly what happened with me in the ice block. And okay, this is fine, easy to visualize. Past the checkpoints, that's when we start to lean a bit on my notes, just to do things quickly. And here's 1, 2, 3. Okay. And there we are. Not exactly setting any records here, but there have definitely been puzzles that have taken me longer. Usually because sometimes, you know, you have to do this extensive cataloging, like some escape rooms where you actually have to jot down the whole alphabet that you've discovered, and which I usually try to do as screenshots, but isn't always possible depending on what the layout of the clues is going to be. I don't really feel like our performance on this puzzle was kind of below average for me in puzzles, but once again, that's because it was very easy to temporarily rely on theories that turned out to be false. And we ran into that problem quite a few times. With both the ice block rules and the blue block rules being severely underconstrained, and that's pretty much the entire level past the pre-checkpoint 1 tutorial. I will assume from the MMC text, though, that we've basically seen the mechanics that are here. The question at this point is, what's the last thing going to be? Because there definitely looks like there's going to be at least one more, especially for the key coins. Okay. I believe this is correct. Got a couple of the 2, 4, 3 1s in a row. 1, 2, 3, 4. We're not leaving this. Okay, so this is something I solved earlier. It's 1, 2, 3, 4. Here's a moment of truth. Okay, certainly I hope we've debugged this thoroughly at this point. There we go, progress. We're obviously going to take the pipe, or whatever puzzle lies beyond. We're not done. Okay. Let me jot this down in my notes first. I feel like we will definitely want the editor for some of this stuff, but again, because it looks like a sequence of 3 rooms, I want to solve the first one on the notepad so we don't have to exit. And hopefully it'll be comparatively easy. Let's take a look at these. Yeah, because then I don't need to go back to this one twice. That might be the wrong way to think about it, though. Just given how much faster it is to do in the editor. And yeah, there is a column 5 on my notepad. We just don't have room for it right now. Let's see here. And then you have the next one with these little clusters everywhere. Top corner. Then we'll just go down. Oops. Go. Okay, let's try to do this one first. Once again, we want to take a look at the corner locations. You know what? No, too fuzzy. We're doing it in the editor. Doesn't matter that we need to retread it, I think. I might regret saying that. Let's copy it out first and just see about its feasibility. I may come to regret this, but okay. So we know bottom is always filled. We know then that we need to figure out a theory for eliminating everything on the bottom. we know that any column could have some blue blocks here because you do have question marks all across the ceiling. But that the blue blocks can only go so far. Can any of these be ice blocks? Yes, only if it's beside a blue block. Because one of these is going to be a column of 5. We're doing this in the editor. Too hard to illustrate this way. That's an extra couple of minutes to eventually get to whatever the last puzzle in his room is, but I think it will be worth it. You know, yeah, let's do it that way. Rebox. Yeah, it takes some explaining. You have 4 different block types in this puzzle. You have P blocks, question blocks, ice blocks, blue blocks. P blocks count up to number of your grid. So if it's a 4x4 grid, they count up to 4. If it's a 5x5 grid, they count up to 5. Question blocks are a wild card. They can be anything. They can also be a blank space. They're unknown territory. Let me scroll to the appropriate part of my notes. So for those of you who just got here, by the way, we are in the bonus room, just so you know. That's how far we are. We have solved everything up to the bonus room. So, ice blocks make a cross. Every time you see an ice block, you have to read it, sorry, like this. Blue blocks are kind of like a waterfall. They're a negative space. Every time you read some blue blocks, you fill in blocks all the way below. And there are some collision rules. So blue blocks, for instance, cancel out ice blocks. And so we've established a rule set over time, and we just need to do a particularly a big puzzle now. Let's use the top half of the screen here as our workspace. We'll need it for some of these 5x5s. Okay. No, you know what? I want as much space as possible. Let's just go to the flagpole and extend it. Okay. Okay, puzzle number 1. Yeah, we want some space so we can actually copy things around. Okay. So, bonus room puzzle number 1 is going to look like this. I have a little bit of stick drift on my Pro controller, which is annoying. We want 5x5, right? Yeah, there we go. Okay, so this is our template. Certainly hope I've copied it correctly. We can always check the screenshots afterwards if we're not sure. So yeah, the columns are going to be in some order, 1, 2, 3, 4, 5. Whoops. And we need to determine what that is just by solving constraints. So here's our little starting constraint here. I just move my stick a little bit so it behaves. Our starting constraint is that we... Wow, I really do have stick drift on this. This is annoying all of a sudden. Hang on. Okay, stop. There we go. We always know that the bottom is filled. So we need to figure out what could possibly have emptied these locations. And the way to do that is to look at the corner pieces. Let me see if I can use a coin as a cursor here. The ones that are basically a distance of 2 apart from the nearest question block are more constrained than the rest, let's say. And so determining what they get filled with or what deletes them is basically going to be the key. So we can tell that this spot where my coin is right now is going to be a seriously important hotspot. Yeah, it's going to be a very important hotspot because it can only be constrained by so much if it is to be filled with anything at all. And indeed, we can take the approach that we did on the last one, which is just to think about like which column is going to be the 1. Which one is going to be the number 1? Because there's a very strong possibility it's going to be this one here. Because in order for this to be anything else, let's consider the first column and what it can be. Can it be a 5? Well, only if you have ways to eliminate all of these blocks, which you will not have. Because you don't have anything to eliminate this other than ice up top. You don't have anything to eliminate this, crucially. This is the crucial spot. Because there's nothing that's within range of eliminating this. And so you know, first one will not be 5. Could it be 4? Potentially. To be 4, you have this. And this creates this kind of pattern. But then, could it be 3? I don't believe so. Because you had 3, once again, you have nothing to eliminate this because you don't have ice in range. In this case, you don't have blue in range. Could it be 2? Very likely that it can be. So we basically can start filling in and saying that it's not going to be 3 and it's not going to be 5. So we can fill this in column 1 by saying 1, 2, 4, basically. We'll basically need to figure out what the most difficult element is going to be. Once you find the most difficult element, then you kind of search for it. So the most difficult one in the previous one, for instance, was where to find a placement of the column that is only 1 tile high. And once we got that, and once I deal with my stick drift that has suddenly appeared in the last few minutes, then... Okay, let's get this under control. Then we try to make our search space as heuristically efficient as possible. That's essentially what we're going for. So we know that this can be 1, 2, or 4 in the first column, and we should consider the possibilities, and we can just, in fact, just maybe copy this out and map it now. Because I feel like, given the nature of the first column, having that 3-tile gap, it's probably the easiest target to work with in terms of what the constraints will be. So, what we'll do is we'll branch this out into 3 copies. This is going to be very disorganized. But we're going to basically do some hypotheses here, where we're going to suppose this is 1, we're going to suppose this is 2, and we're going to suppose this is 4. Let's do it this way. If it's 1, then we just start solving it accordingly. Where we have this, we have this, and we try to constrain it. So we're looking for contradictions. If it's this, then we need to figure out how this would have gotten eliminated in either location. If it's this, why do we believe it could be 4? Because that's what you would have here. So these are the, if you're just looking at column 1, these are different layouts that you could potentially be working with. And now we need to figure out what eliminates the blank spaces in order for this to work. So, in order for this to work, of these 2 locations, in order to... Actually, this isn't really constrained yet. But for this one, in order to eliminate this block, either this must be ice or this must be ice. And we might have to follow that logic and see where it takes us. But if the 1 isn't going to be there, you need to find the 1 somewhere else, right? So the next thing that we should look at is, again, corner pieces of some sort. So you have a 1 over here. Yeah, we've eliminated 3 and 5 for reasons I specified earlier. But you've basically got these possibilities. And again, it's a kind of distance of 2 that is going to be most useful to work with here. Because let's say we look at... Because anything that is a distance of 2 away from a question block, away from any question block, you know will not be reachable by ice, and accordingly can't be eliminated. So for instance, because here, you know that there's nothing in this location, this question block must therefore be a 2. How do we know that? It can't be blue because blue is not reaching all the way down. It can't be ice because ice would have created a block next to it. And it can't be blank because we already have a 1. So here we have 1, 2. There we go. Next. So the remaining columns under this theory must all be a minimum of 3. And in here, once again, we have nothing. So if they're all a minimum of 3, we can start filling things out. And then we need to establish, once again, a theory for how all of these spaces get emptied. These could be blue blocks. But remember, one of these columns will need to be a 5. Can this one be a 5? It can't. Can it? Yes, it can, actually, because maybe these 2 are just P blocks, and that's not an issue. But then you would need to establish who can be the 4. That's actually possible. Let's copy this, because this is promising right now. We're going to totally lose track of our notes here. So this branch is the one where we're considering 1, 2. So let's say that we're confirming 1 and 2 in this location. We have 2 possibilities. We need to look over 5, because I think 5 is the hardest to constrain at this point. We know that in order for this to be 5, 2 around it would have to be blue blocks. For this to be 5, so there are a couple of possibilities. So let's say we do something like this. So we're going to suggest this is 5. Can we constrain these other ones? Well, once again, we need to figure out a way to eliminate blank spaces. We need to eliminate all 3 of these. Particularly this one here. Can we do that? I don't think we can. We don't have a way to take out this piece. So, I think this theory doesn't work. I'm going to go back. In fact, I think that has to be 3. It could be 4, but you need a blue block because otherwise you have no way to account for this space. So, I feel like we're definitely constrained to blue. At the very least. Which means one of these remaining columns has to be 4. This could be 3, this could be 4. One of these 2 remaining ones will be constrained. Now, here's the problem, is that if we have a particular theory, we need to check it very carefully, because it's going to take me a few minutes to get all the way to the end of the level and back to the bonus room to actually test this stuff. Which is why I really should have considered just dual streaming with the Wii U and using the Wii U screen to do this. Anyway, we need to, once again, we need a more direct comparison here. Let's move it closer to the original grid. so we can actually see what's going on. Because we need to see which spaces have been emptied out. So can we account for each of the empty spaces that are currently filled in? This would be emptied if this is blue. That's fine. But then that means that one of these has a 5 in it. Suppose you have this. Then you can have this. And then suppose... And then we have to determine which one is 4 and which one is 3. If this one is to 4, this one is to 3, then... Yeah, we need to check each of these spots to make sure. So we already have a bit of a problem here, which is that we have nothing to eliminate this location. We don't have an ice block or something that would be able to account for it. So we actually already have a problem with this whole theory. That if you have P block here and P block here, you can't do anything here. So I feel like this grid has already been shot. Because this forces this to be 2. It actually can't be anything else. But if this is 2, then nothing deals with this block. Because neither of these can be ice. So let's just scrap this. This one is dead. This one is definitely dead. Pretty sure anyway. So let's narrow the tree a little bit. Suppose this is 2. What can we say about the constraints if this is 2? This could be ice. This could be ice. But one of those would have to be ice. So let's grab this. Yeah, let's just grab it like this. Let's copy it over. And let's just compare these two grids. This is not a very organized way of doing it. Just use a piece of paper? Well, I can't stream that now, can I? Yeah, I'm a little extra constrained here in terms of note-taking because, you know, we are streaming this. And I have stick drift, which we have to stop this somehow. It's unusual for my Pro Controller, but occasionally you have some camera spinning that goes with it. Okay, so we have two possibilities. Either this is ice, or this is ice. We're going to check this one first. Again, this is the one where we have designated this as my 2. If this is ice, then this could still be anything. But it probably can't be anything more than 3. At most, it's 3. And it's only 3 if this is also ice. And this is also ice, then you've got 2, 3, 2. And then you start running into some questions about whether there can be a 1 beyond that. Let's check this one too, just to see what kind of constraints it forces. In fact, this one, if this is ice, this would be a subset of this puzzle here, because, like, it doesn't matter if this is ice or a P block if this one is ice. So, we'll leave this on the back burner for now, because this will be the theory that the second column, well, it wouldn't be P either, because then you would have 2 beside each other that are both 2 tiles high. So this would actually be 2 and 1. This one, you're not committed to it being 3 because ice could imply some blocks here. So for example, if this were ice, then this could be 4 high, and potentially even 5 high. So we don't actually know enough about this right now. In fact, there are some interesting implications here. Because we still need a 1. This will not be the 1. Because this will be filled in. This will be minimum 3. But if this is not going to be the 1 column, then one of these two has to be the 1 column. I mean, these two could just be blank blocks, and then that would solve that problem. Then you would need to find some other kind of tower up here. If this is 3, can we still reach up to 4 and 5? Potentially. This is a very thorough series of constraints here. I really hope we can finish it in today's stream, because I'm beginning to think that's by no means guaranteed. But anyway, like I said, we'll set aside this branch. Let's explore this branch and just look for the contradiction. So you have 2, you have minimum 3. You have this minimum 2, which means that this will need to have something additional to it because we already have a 2 accounted for. Whoops. Hang on. Therefore, we know this will be minimum 3. In order for this to be minimum 3, this block has to be eliminated by something. Could be blue, it could be ice. But either way, it has to be taken out by something. One of these two has to be a 1. If this is a 1, then you can eliminate these two. If this is a 1, then you eliminate both of these. And if you eliminate both of these, though, then you have a problem where this will also be at least 3. And you have no way to get rid of all that stuff. I don't think. So this can't be the 1 column. The right side would have to be the 1 column. Which would make this and this the configuration. That would mean that we have enforced a minimum 3 over here. And that creates the contradiction, I think, because the only spots that can eliminate this are this and this. It's not going to be this. So it has to be this. But if this is ice, this creates 2 over here. You get your contradiction. So I think we can eliminate this branch. Because this implies at least 3. But more to the point, this implies 1 has to sit here. There's nowhere else it can sit, I don't think. So, we know this will not be ice. This block here will not be ice. If the first column is 2. So, let's go with this again. You have 2, then you have 1. That means the rest of these have minimum 3. Like this. And then we need to find a way, once again, to eliminate everything surrounding. You can't have ice up here because this block will get in the way. So this will be 4 maximum. One of these will be 5. We don't know which one yet. This could be a P block. It's not impossible. But then you would have no way to eliminate this spot. This spot needs to be eliminated somehow. Or implied, rather. I keep saying eliminated. That means this must be ice or blue. It can't be ice because ice creates problems on the left side here. So this will be blue. Which means you have, a guaranteed 3. That means you have 4 and 5 in some configuration over here. Let's make sure we can eliminate everything, or rather imply everything else. Okay, this goes down. That's fine. We need to take out this location. This corner piece is something we should be looking for. The only thing that can reach this is blue, which means this is blue, which means this is 4, which means this is 5. In order for this to be 4, we need to figure out how to remove this. That's simple. That's just with ice. Ice has been cancelled out on either side by these blue pieces. You go down here. We'll need to check every location that has been removed somehow. We got 2, 1, 3, 4, and then 5. This has been removed by ice. We can do ice over here, and that takes care of these blocks. And then what do we do with this guy? Well, we don't need to deal with anything on the left side here because that's already been all accounted for. We need to then account for this block, which has been done, and this block. I think ice is just fine. I think we have this. That actually works. And then we have 2, 1, 3, 5, 4. I'm going to jot that down because I feel like that's actually going to be consistent. We'll check it thoroughly first. But I believe it will work. We are a better bonus room going here. I better screenshot this because we learned our mistake. We learned our lesson, rather, earlier on about restarting the whole thing and not being able to do the error check properly. Okay, let's go through this carefully. We're going to do the question block path to make sure the question blocks all line up, and then we're going to do the blank path to make sure the blanks all line up. Question block all across the top, that's fine. Here, that's fine. These 2 spots, these 2 spots. Great, and don't have any additional squares anywhere else. Now let's do the blanks. Okay, so these spaces we don't need to care about. This space covered by ice. This space covered by ice. This covered by this column. This covered by ice. This covered by this column. In fact, does this even need to be an ice block? Yes, it does, because I don't think it does, actually. Because this is already taken care of here. So what happens if we just... I think this one is actually ambiguous. I don't think it matters what it is. Because if this is blue, all of this is taken care of. And the only thing that we were worried about was this spot here, which is now covered by this. So I think this is actually the solution we're looking at. Let's screenshot this instead. And then let's go to the next puzzle, because there actually is another one, and possibly another one after that. So we can eliminate some of this stuff. Let's clean up the notes. And I think we're fine. Okay, let's do another one. Yeah, so I think this is going to be right. 2, 1, 3, 5, 4. Okay, we need to look at the second puzzle in the bonus room now. Which is going to be this set. That took way too long. I feel like we didn't take the most efficient path to constraining this, but I'm glad I took it to the editor, though. I feel like that would have been an absolute mess to work through on the notepad. Okay, let's copy this as a workspace. And let's fill in the things that we know. We know, as usual, that we can fill in the bottom. Whoops, let's hide notes. Yeah, we know the bottom can always be filled. Now we look for the places that are a distance of 2 away from any other location. So we see a couple of candidates here. We see these locations, which can't be touched by ice. These can both be touched by ice, so we don't need to worry so much about that. But this one, you would need ice here, and then you would need to... so yeah, no, we can't reason anything about this just yet, but I'm pretty sure we can establish, given this, and given this location here, that we're going to have some blue up top. Yeah, because this is unreachable by ice. These two are unreachable by ice. So, we already know that we have 2 blue columns. So the question is, how low does that go? Well, we know this location won't be reachable by ice either, since it's no longer beside an ice block. And because of that, and because there's nothing else that can go there, we have our 4. And that's been guaranteed, I'm pretty sure. Because that's a 4, we know that's a maximum of 3. And once again, now, is it possible for this to be ice? No, because we already have a 4 accounted for. So this is going to be R3. For sure, in fact, because this piece can no longer be touched by ice either. So we have our 4 and R3. It's actually rather simple, comparatively. So the remaining ones have to be 1, 2, and 5. Let's think about it. So we need to think about Welcome to Playhouse. Yeah, that's pretty much exactly what it is, Sergey. So this is going to be 3. This will be 4. You know that this had to be removed by something, and we haven't accounted for that yet. But it can be removed by ice. Or not removed, implied by ice, rather. This could be 1 or it could be 2, depending on whether this is ice. However, if this is ice, it makes this 3, and it's not going to be 3. If it's 3, then we have 2 different 3s. However, it's possible for this to be 4. No, it's not, because we need to think about... Yeah, one of these is going to be the 5 column, and I think the 5 column is actually going to be the hardest one to determine here, so we need to figure that out. Because the 5 column is actually the real problem. So suppose this is the 5 column. Then we need to figure out what removes this, what removes this. Well, let's fill in and find out. In order to do that, we would need this to be ice to take this out. You would need this to be ice to take this out. But then you have a lot of mounting complications because suddenly you don't have enough to constrain that. So I feel like that cannot be the 5. This actually could potentially be the 5 if you think about... no it can't, because it would need to be removed by ice. That would create 2 columns of 5. That's not 5. Then let's suppose this is 5. That's not going to work either, so I feel like we've reached a contradiction already. There's nowhere for the 5 to go. So did we do something wrong? Well, we need somewhere for the 5 to go. Have we considered that this could in fact be 5? Yes, and it's not possible because we just don't have the pieces available to eliminate any of this. Do I know who Sergei Smirnova is? No, I do not, I don't think. So unfortunately, the joke is lost on me. If it is a joke, it might not be. So where is the 5 going to be? If the 5 is in the center, it's actually possible for the 5 to be at the center, isn't it? But then one of these would need to be ice. So you get 2 columns of 5, that's wrong. What if one of these is a P block? Let's say you have this as your 5. And then you have this. That creates a 4. That enforces this. This would then require... Ooh, yeah, no, you have a problem here because we don't have room for another 4. We already have a 4 accounted for over here. But this isn't necessarily 4. This is my assumption that it was wrong. This is wrong. This doesn't need to be 4 because if one of these bottom blocks is ice... Yeah, this is the problem that we ran into. This could be something really low on this side. 4 creates a contradiction. This could be a 1 or a 2. In fact, it's the likeliest candidate for 1. Let's try it with 1. If we try it with 1, then this actually gives you ice. And then you get something like this. So this is 1, 2. Now does the rest of this work? I think it actually does. I think this actually works. Let's test it. Let's go over this with the question blocks to make sure the question blocks all match the valid locations. Here, here, here. And no, Sergey, I'm afraid the conversation you're having with yourself is completely lost on me. Partly because I'm focusing on the puzzle, but... Anyway, we do have a solution now that gives me 1, 2, 3, 4, 5. Now we need to check each of the slots that we need to eliminate. So, this column is completely taken care of by this. This column here, the missing spots are these 3. Ice, ice, ice. That's good. This one here, empty, that's fine, we don't care about that. This one is taken by ice, this is by ice. This one here, these slots are empty, so we don't care. This one is the only one we need, and yeah, this is correct. 3, 5, 4, 2, 1. I think we have it. So let's go punch these in. This was actually a much easier one than the last one we did. Let's play it, let's go back to the bonus room, and if the layout is similar to the previous layouts, there should be one more puzzle in the bonus room if it's a set of 3. No, what am I doing? I'm reading too far ahead. Let's redo this. Let's just do the obvious thing. There we go. Okay. We'll just retrace our steps. It's going to take a little bit of time, but once again, for clarity's sake, I do think it was worth it. Okay, here we go. Now, after this, I will see... Well, we'll see about the potentially last puzzle, first of all, and then we'll see if we have time to actually stay for Troll at the end. Yeah, because I was hoping that this would be just an easy clear of the rest of week 4 today, but I don't actually know if that's the case. Yeah, here we go. And this is going to be a 1, 2, and 3. And once again, we'll do a couple of these. Well, once this is where we're getting into my notepad, so it should be fairly simple from here. Okay, good so far. 1, 2, 3, 4, 5 with our old nemesis. Okay. This is fairly self-explanatory. This whole blue block tutorial section. And we're still okay. Plenty of time left on the clock to punch in some of this stuff, and we'll have to see what the final piece is. That's the unfortunate cost of this method, but it's no worse than a lot of the other repeats we do when we do puzzles. So, just a little bit of extra lag time as we get back to where we're supposed to be. Okay, once again, the whole 2, 4, 3, 1 sequence. I have to remember to read my notes accurately, because as I always say, when you have sequences of numbers, it can actually mean two different things. Where if you read like 1, 2, or 4, 3, 2, 1, does that mean you're going 4, 3, 2, 1? Or does that mean these numbers are 4, 3, 2, 1 and you're going in reverse order? That's a bad example, but anyway. So for example, I got 2, 4, 3, 1. It does not mean 2, 4, 3, 1. It means I've assigned the numbers 2, 4, 3, 1, and we go in order. 1, 2, 3, 4. And with this puzzle, it's actually fairly clear because, you know, you're solving numbers that are stacked additively anyway, but it's an occasional pitfall that I see with people doing escape room clues, that they don't realize that sequences of numbers can be interpreted in two ways. It's a very common design error. Luckily, here that's only relevant to our note-taking. It's not something to do with any kind of code entry in the puzzle itself. So, any errors here with understanding my notes is entirely my fault. And yes, Mang, you're absolutely correct. It is puzzle time. Although I guess maybe it's story time since we're repeating this early bit here and trying not to touch the flag. Look at that one up off the top corner. Okay, moment of truth. 21354. Good. Next, 35421. We can strip off the question marks afterwards if we did this correctly. And as expected, there is one last puzzle, so we'll need to look at this again. Okay, so it's a 6x6. We are definitely taking it back to the editor. No way are we going to try to do this manually. However, I am going to try to jot this down on my notepad first, so we don't need to skip back and forth to the screenshots. Love the little heartbeat here as well. But yeah, we are definitely going to take this back to the editor. Luckily, lots of blank spaces here. And I feel like it's probably not as bad as it looks, given that the blank spaces add significant constraints. Anyway, this is the 6x6 grid. I think I've notated it accurately. Let me just make sure so we don't mess ourselves up. Let's go back. I feel like ultimately this will save time, so. And then we can even get a reasonable time on the level, even if it's not a record. How much space do I have here? We need to extend a flag. But I feel like with practice, we've actually developed a good method of how to denote this. I feel like the note-taking has improved with time. And I hope that's true of the viewer experience as well, although I realize, of course, that this is probably pretty tedious to watch if you aren't already invested in the solution. Because it is just a lot of paperwork. Well, no difference in doing things like chess tactics puzzles, I suppose. Okay. We need to, of course, save the initial layout so we don't mess around with too much. And let's do a workspace. Okay, let's start filling this in. Okay. Well, there's our ones. We have a lot of blank spaces to work with that will be useful because we can kind of designate them as spots that will not be touchable by ice. Let's actually designate them with some coins here. We'll eliminate the coins afterwards, but I just want to mark these spots that are unreachable by ice, like these corner locations, because they are the best constraints that we have to work with. Because the corner locations tell me that if it's unreachable by ice, nothing will be there. Particularly not in these columns where there's nothing above. So I feel like we already have a pretty good head start. And I feel like this is maximum 3. Like, we'll use coins to denote some constraints here. So right now, coins down here denote maximum, not our guess, but just a maximum. The 6, I think, will be interesting to look at, because our options for where the 6 will lie are going to be fairly limited, given, once again, the massive open spaces that we have. Here, for instance, we know that this is untouchable by ice, and so nothing will be there. The 3-tile gap tells me that it's also not going to be blue, because we just won't have... Well, if it is blue, it has to be like this continuous column that reaches down, and nothing will eliminate this location. So I feel like we've got something already. That's going to blank out. And we can just eliminate that right off the bat. Also means that this cannot be ice. And because of this spot here, that is once again unreachable, it's not going to be a blue block either, because blue... maybe it can be, actually. Because if you have 2 blues down here dangling off the ceiling, you can have a continuous string. Why was it I eliminated the possibility that this is blue? And creating just this huge column here, because, once again, there's nothing to eliminate this location. Yeah, because there's nothing that will hide it. Well, except the blue block itself, right? Blue can just... The blue block already hides everything underneath it as a continuous column. So yeah, we shouldn't eliminate that yet then. Let's leave that as is. And let's think about this. It is absolutely art time, that's correct. So, we need to locate the 6. And the elements that actually have some density to them. So we know from previous experience that when you have these kinds of corners up top, that's very important information, because if you have ice, it creates a second column that is equivalent height. So, and that creates too many columns that touch the top. So you can always have something like ice, blue, for instance, potentially. Or you could just have a P block, and then nothing or blue. Now, because of this 3 space over here and this 2 space over here, I feel like ice and blue is actually a pretty reasonable hypothesis for what's going on over here. You don't need ice for it, actually, because it won't do anything in that kind of location. You would need it potentially here, though, to fill in something like this. And then that would fill this in. Like that. And let's think about that, because you would need to remove this. And to remove this, I mean, you can rely on a blue block to just cascade all the way down. You know this can't be ice because this location... no, it can be. It can be, potentially. We can't eliminate that yet. And this could also just be a P... No, it can't. It has to be ice. Because if this is blue, this has to be removed. So let's suppose that this is 5 and 6. Then one of these two has to be 4. It can't be this one, because nothing will touch this location. In fact, at this point, because we know that this will not be 5, we can eliminate this. And this will be our 4. And then we have a pretty good working theory for how that's going to work. Here's our 4, 5, 6. Now we have 3 columns here that are all 3. And one of them will have to be 1. If this is 1, this is 2. But then we don't have a good way to do 3 unless we use ice in both these locations. Which we can. It's possible for ice to be in both. If ice is in both, here and here, whoops, here and here, then you get P blocks down here for the 3 set. And then you get potentially 1 and 2. Now, why would that be a contradiction? Let's test that. We're going to set some boundaries here. Just set some constraints. So right now, any of these could be 3. We're going to try to eliminate something. The most sensible thing is to think about this as potentially a 1. And you just have P blocks going all the way down. But we need to think about eliminations right now, because... yeah, so the thing that we need to think about now is how these spots... whoops. How these spots all got emptied, because we actually have a problem. This corner here. We didn't account for this corner. This corner actually creates a situation where there has to be a blue block above somewhere. So this is wrong. This is wrong. There must be a blue block in this column. Which means that the 6 is going to be elsewhere. The 6, I think, would therefore have to be here. And then this would get eliminated here. And then you would create this. Electrodude, did you do the bonus road? Or not? Anyway. Yeah, no, you know that this has to be blue because of this corner. That something has to fill in this location, and the only thing that can fill in this bottom corner has to be a blue block. Same with this. You know that this has to be blue. Possibly this could be ice. No, I don't know about... No, not enough to cover this column. Oh, you're confused by the chat. You also did solve the bonus puzzles. Okay, great. It is story time and art time. After we finish this, then it's a wrap. Okay, I think this configuration actually works. Because the question block covers this P block. Ice covers this one. Ice covers this one. Then, you need ice to cover this bottom location, for sure. So all of that is covered. This column is completely done. This block does not matter. At least I don't think it does. This would then give you 3. 3, 6, 5, and 4. That means we're down to these 2. We need something to eliminate this location here. 2 possibilities. No, 1 possibility. Has to be ice here. Can't be ice here, because that would create an additional spot. Ice is going to be here. Creates this. That creates this. 4, 1, 2, 3, 5, 6. Let's check it. Let's check it. First, we're going to do question block coverage to make sure that the question blocks match up to the spots that have the bonus blocks. Here, here, Here. Here. Good. Now we do the blank space check. So, yeah, I know we took ages to do this level, but by the end, I think we actually had a systematic method for it. So, this column completely taken care of by the blue blocks. Great. These spots don't matter. This spot taken care of by ice. Then let's do this column here. This ice. This ice. This ice. This column. This ice. This ice. Ice. This column, yeah, this is taken care of by blue. Everything else falls into place. This block doesn't matter. So, let's get this into position for a screenshot so we can check our work if necessary. And let's jot this down in the notes. And then hopefully we're finally done after a 4-hour stream of this level today so far. Plus the time that we spent on it last stream, I guess. This is one of the longer ones we've done, but well worth it, I think, and hope. 4, 1, 2, 3, 5, 6. Alright, we should be finished at this point. Okay. Let's turn the notes off until we need them. Just to have less of an obstruction. So, my intention is to continue to the troll level. I do not know if I'll be able to stay long enough to finish it, depending on its scale, because it is the Mega Troll Collab. I will unfortunately probably not get to the 69 MMC collaborative level by Luca and Meng today. I was hoping to do it. But if we do viewer levels later in the week, maybe we can put it in then. I was really hoping to get to it. That was the thing I had in mind if we managed to finish the MMC levels early enough, but we're running a bit late as is. Okay. Just going through the motions at this point. But I believe we have it. Yeah, we could have saved ourselves a lot of time if I had applied some of that note-taking methodology much earlier. Because I think it worked out in the end that you just, fill out all of the implied P blocks as you go, and that actually cleans things up substantially. In terms of just making things easier to visualize. And by the time you get to the end of something like this, it becomes a little more fluent. Anyway, through this tutorial segment. Kinda wish we just had a single passcode lock for the earlier sections to get you through to the other checkpoints, but I guess we're probably pretty tight on entity limit at this point with all the skulls. I'm thinking back to how in Mario Maker 1, before checkpoints were introduced, people would actually come up with some pretty interesting passcode entry systems to save progress in things like Metroid-style levels. You actually think Ruben had a lot of entities left? Yeah, I guess maybe it's just skulls and they're pretty spread out per room. And the mechanism has to be pretty simple, so who knows? Anyway, yeah, this is gonna be checkpoint 2. Let's do this. And you've got the whole 2, 4, 3, 1 set here. 3 of those in a row. I guess it just happened that way with these puzzles. I may want to check the level overview afterwards. Interesting. Oh yeah, I think I heard Ruben say something about there being references to other games, but I really can't see what that would be unless it's something to do with some of these patterns. But what are we doing here? Oh yes, that's right. Lost my place momentarily and what I was doing. Okay. Okay, moment of truth is coming soon. This one here we've entered previously. And this one succeeded on the first try as well. Actually, with some of these more advanced solutions, it is interesting to see how relatively quickly they came together, because there's so much blank space that it does significantly constrain on what you can do with it. The playtesting must have been quite something in this level. Anyway, we have 4, 1, 2, 3, 5, 6 here, so let's try it. No, hang on. I notated this wrong. It was a 6 and a 5, wasn't it? Let's check the screenshot album. Six and 5, yeah. I actually jotted it incorrectly in my notepad. That would have been a disaster. That's why we took the screenshot. Okay. I feel like we want to leave a card here. Yeah, I'm not the only one with this idea. Yeah, let's leave a card somewhere nice and open. We want to be lazy about it. Speed run. Can't be bothered to do the full artwork. Let's take a look at some comment artwork by anybody who got here. Looney was here, I suppose so. Anyway, nice balloon. Comments off. Oh, so much for that. That was satisfying. We've got to check this. Nope, nothing. Didn't think so. We will not even catch the top of the flagpole.
Oh yeah, Mario time!
Oh, I had my notes open the whole time, obstructing that clear screen. That's okay. We got it. Anyway, 6 minutes 23. That was pretty quick, actually. We didn't take long on that one at all. Let's at least start to troll. I don't know if I'll be able to finish it today, but we'll see how it is. I'm a goofy goober. Let's take a look at comments first. And oh, this guy trying to leave some spoilers. Didn't have enough comments left to do the actual hard puzzles, though. So. And oh, this is clever. Very clever here from Nabuz. Nice one to hear from Barnstorm, too. Mario discovering the Rosetta Stone. Taking it to be appraised in Animal Crossing, and, you know... Oh, hey, Mang left a heart. You'll notice that the blue block on Mang's layout here completely violates the rule set. Okay. Oh, it doesn't? Let's take a look. Yeah, no, it doesn't, because if you see... Oh yeah, no, these are question blocks on the left side. So the left side is actually just... Yeah, the left is going to be 1. I'm mentally solving this because that's the way things go. No, because if you look at the top right corner, you have a question block and an ice block, and both of those would be 5 tiles high. The top right corner, both of those are 5 tiles high. Right? I mean, nobody's expecting you to actually have created a 1, 2, 3, 4, 5 arrangement. So, like, within the constraints of what the blocks are allowed to do, this is obviously perfectly valid. But I feel like the Mang avatar here is looking at the top right corner and going... Oh, no, because the question block there could also be masking a blue block, right? If I'm looking at this correctly. Yeah, if the question block there is a blue block, then you've got a maximum 4 on that column. The rightmost column is definitely 5. Leftmost column is definitely 1. I actually feel like this is just 1, 2, 3, 4, 5. That's the solution. 1, 2, 3, 4, 5. I totally see it, because in a top row you would basically have blue, invisible, blue, blue, ice. Second row would be blue, and then blue, and then P. Or, actually, no, ice. Blue, blue, and then ice. Yeah, no, this is 1, 2, 3, 4, 5. That's the solution. So, anyway, full credit to Mang for actually making this a coherent puzzle. I'm glad I actually stopped to solve it for an actual bonus. I don't think Nabuz's worked the same way, but I'm going to screenshot this actually because Mang actually created a bonus puzzle, and I feel like this is well worth remembering, especially in case of a re-upload or Nintendo nuking it for some reason. Okay. This stream has been running really long, but I'm a goofy goomber. Troll collabed with 9 other makers. Version 17 at least seems to have remained stable. The description on the website says, if you're not playing this level, you're going to turn into a Goomba. This is hosted by Bearware, actually Bearware's alternate account. This account currently has nothing else on it, I don't think. I need to play the Bear24 puzzle series at some point, actually. That's been a puzzle world that's been sitting in my backlog forever. But anyway, enough about Bearware. He also collaborated with Wilfred Stevo, Soup Bowl, Daft Life, who was here earlier in the stream, and Bedcliff, Foggles, Major, Marble, and Box. We've played Trolls by some of these people, but not all. I'm not very connected to the troll community, but we've played some by Major and Box and Stevo, at least, I think. Possibly some others. Shield, sir, you're here for a very thematically appropriate event, given your specialization in this game. Like I said, I don't know if I can actually stay long enough to finish this today, but we'll at least get started. Ruben did want to re-upload because of the hollow square puzzle being too big of a difficulty spike. Well, too bad for him. No, it's a difficulty spike, Electrodude, just to comment on that, just because of what I said earlier, which is that it's possible to get all the way to that point without fully understanding the rules. And so it just comes as a very late check on whether you understand ice. And I don't know if there was a better way for the earlier puzzles to communicate that in a more gentle fashion, but maybe Ruben came up with something. I don't know. Oh, this is a troll. We should probably pay attention to the mechanisms we're activating here. And applause. And it shows you that there's a pipe down below. Now, this being 7MMC, I'm sure it's going to be relatively gentle, and it just reveals information as we go. So, there we are. Down low. Yeah, we need to kind of stand on half and then toss a POW, right? We'll need to figure out how that works. Like, do we stand on one half? Yeah, that we do. And then we jump up, and then that's the correct solution. But we just need to execute that mechanically. Yeah, Electrodude, because that was the issue I ran into at the end of last stream too, right? Is that the interpretation of the ice as a bomb seemed perfectly valid. I feel like this was meant to try to push me into the top and that we're going to go for the 50 coin anyway. Shields, you were asked to make 7MMC level, but the timing didn't suit. Yeah, I kind of wish I was able to put one together this year as well, given that I had a blast working on YMM in the past, but this year was absurdly busy for me, so. Alright, let's see what we have here. I'm sure that's going to be something I don't want to do. Anyway, are we within range of something important? Probably. I feel like we needed to grab this and then toss. And lose it. And that's what this is for. Do we need to do a little jump there? Or stand off to the side? Let's see. Okay, down we go. And yeah, okay, that's how it's supposed to work when you don't just get hit with the SMB2 mushroom. Interestingly enough, you have cloud platforms there that seem to imply that you can go back down with the SMB2 mushroom if necessary. And so we should take that into account, that potentially we might actually want to pluck the clouds down if that's the way things go. Interesting that it... Yeah, I guess that's just a bit of a gentle check that's an interesting collision there. That took me a little by surprise. And yes, there is much to share, Sergey, in Playhouse Twitchland. Very much indeed. Yeah, so it gives you the SMB2 mushroom again, just in case, but we... I mean, I didn't even hit that question block previously, did I? That's why we didn't run into trouble. Why don't we just drop this? Now what do we do? Master Sword, and then it takes you through the POW. So I think we just stand on the munchers on the right side, let those fall, and then we just continue from there. We'll go back and see if that's the case. Okay, here we are. Okay, there we go. And then we spin jump our way over to the Goom Split. Goom Split's right and left. We just need to hold right into that, actually. Okay. I don't know the troll community well enough to have any clue as to who did what. I know that in puzzle collaborations in the past, I've actually been able to usually tell the contributors' identities just by various stylistic tics, but I don't know trolls well enough to do anything similar here. Okay. That seemed to work, surprisingly well. Let's go left. This is suspicious. Warp zone? No. That's a very nice one. Very innocuous. Yeah, interesting collision with the Goom Split earlier. We'll keep that in mind. Because I didn't expect to get out of the Goomba Split unscathed. And yet we did. So. Okay. Drop. Stand here. Then, yeah, left. Not even going to check the right side, actually. I feel like that's going to be a red herring for sure. And, oh hey, we found a balloon room already. Works for me. Snake blocks go anywhere? It's the Thwomp. Interesting. Let's tease the Thwomp. Okay, nothing. Nice balloon, though, with that Thwomp. Shields are Sonic coming a mile away, yeah. As you would. Okay. Starting to lose my voice a little bit. I've been streaming too long today. But we'll take it easy with rest here. Ups all over the place. We'll just explore this. Oh, yeah, and it blocks the door. Okay, that's fantastic. That's actually a very nice little trick there. Blocking the door on your way out. I do want to just, you know, grab that 1-up up top just to compensate for this, but... Oops. Oh, okay. Cloud on the top of the bumper. Let's be mindful of that. There we go. Can we trigger anything here? Nope, I guess we'll just take the death then. Very stylish. Now, I don't know if reloading from that position of the bonus room and coming out of that door would do anything for you, but... Because maybe there's some kind of spawn positioning that would affect, but... Until we've seen anything to that effect, let's continue. Okay. This looks interesting. Interesting. Okay. I didn't know what the positioning was going to be. I kind of thought it might be something like that. I was actually on alert for moles, in fact. Whoops. Because I thought something like a mole bump might be possible. Let's adjust our angle here. Yeah. Okay. Once again, let's actually adjust our jumps to get back to where we were before. Okay, here we are. But yeah, it seemed like it was within the imprimatur of 7MMC for the trolls to be relatively gentle and introductory for people who normally don't play them. I'm not as new to trolls as some people might be expected to be, but yeah, it looks like the idea is that we want to sneak down to the lower level as we did before. We should have time to do that. But so far, yeah, everything is pretty well flagged. Not a lot of guesswork or anything. It's just a matter of seeing the traps and feeling clever if you do in fact see them coming, which is no guarantee of actually dodging them. Left side by the one-way panel, I think. There we go. That could have ended badly. Okay, Goomba bump something. Let's bump this thing. Once again, thought we were so clever. That actually is correct, I think. We just need to go left afterwards. Okay, down we go. I saw that seesaw in the bottom right, in the first screen. Kind of wonder what kind of launching lies in store. It will be something. Okay. Alright, let's do this. There we go. I feel like this spawned something that would block me. Let's not do it. Okay. Off switch is going to... Well, it's going to be within claw range to drop to Goomba. Goomba walks over and theoretically gets up to the Twister. Theoretically. The idea is that you want to drop the Goomba onto the block for the key, but there's going to be some kind of trick. Like how it goes this way instead, so... Yeah, that's the trick. Is that its direction gets swapped. So... You interpret it as a hint. A hint? Interesting. So you actually need the Goomba to overshoot and come down towards the block when it reverses direction. I think that's going to be the answer here. And so perhaps if you interpreted the track direction as a hint, rather than just saying that the key is attached. It's on the right track. In more ways than one. Oh, like you were supposed to hit a note block, I see. Okay. Yeah, pretty gentle troll experience so far. Just have to stay light on your feet. I guess I should check that someday, but at the same time, I do want to improve my chances of actually finishing this today. So we don't want it to get on the conveyor, we want it to come down this way, and it missed. Okay, so it's going to be one block over. Can we spawn another one? We cannot. So yeah. We just overshot slightly. We probably want it maybe one block over. It takes a little bit of trial and error, or at least better perceptual skills than what we've demonstrated here. Alright, here we are. Okay. Very kind of that 1-up to just be a 1-up. No shenanigans attached. And I knew that was going to be a problem, I just didn't time that well, because I was thinking as it was coming down, it's like, huh, I feel like it's actually going to obstruct me, and then I was too busy thinking about that to do anything about it. In spite of the fact that that was pretty clearly going to happen. Too busy thinking about that bounce. Oh, whoops. Fine, 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 we'll take it. Alright, here we go. Okay, here we go. Love that round of applause. For minor tasks like what we've shown off so far. Okay. Alright, let's watch our trajectory this time. I do need to hit the on-off switch a second time. That's okay, we can do it. That looks like a checkpoint flag, but you never know. Okay. Can I try to grab that? I don't know if I can. Doesn't look quite feasible. That's okay. You never know what kind of checkpoint trickery lies in store, of course, in a troll level, so... And we were likely to die there, so we'll respawn from checkpoint and see what happens. Yeah, I guess all that isn't opening up this time. Nice double bounce. Kind of wonder about those question blocks on the left side. Okay. That doesn't look suspicious at all. Interesting. Okay. Yeah, I guess we need to stay on it. The note block, again, is a bit of a distraction play there. Okay. Pretty simple to work around some of the things we've seen so far, so... Look at that fishbone just coming down like that. That doesn't look suspicious at all. Okay. I was just a little late on button to do what I wanted to do there. There's the vine to grab onto. I don't think you actually get in the boot for the jump out of it, so we'll adjust. Pretty straightforward in this section so far. Okay. Hey, look at that icicle there, adding a bit of an extra constraint, in case you're not paying attention. Very suspicious. Okay, just going to think about that activation range and see what we can do differently. Whoops. That's not a troll, that's just sloppiness. Pretty simple to execute it again, at least, as we get back in. That did not happen previously. Yeah, I guess if it's just on the track in the middle, we should be aware of that. And look at that cavernous bulb to the left there. Yeah, I guess we just need to jump towards it like this, and then that avoids it entirely. We just naturally avoided it the last time, and I guess we just need to hang left, perhaps, and see what happens. Okay, that's fine. Okay. Now we're missing a boot entirely. I needed to jump off of that second one, that's all. That's a neat little element there. The double boot surprise. Shields are taking a child to school? Yeah, have a good time doing that. Safe journeys to you both. That may or may not be done by the time you get back, but, you know, we'll know soon enough. Okay, here we go. Jump towards the side this time, just to be extra cautious. Okay. That was correct that time. Not too difficult to execute now that we've seen it. Now, what is this all about? I love these overlaps, always very satisfying. Okay. Well, this face here that's shooting a pipe at me doesn't look ominous at all. I feel like we probably were supposed to stomp that muncher there. This looks like an anti-soft lock, except of course we... Oh no, it's just a key segment here, except it's possible to fail it. So... I don't know if the Goombas there are spawning continuously. They might be. They might be spawning continuously, but I'm not sure if that's the case, so I guess we'll just punch this for a while. I mean, the spike to the right pretty clearly implies. Okay, I think, first of all, Oh, okay. I was hoping that would work, that you would use this deflection. And that would do something special. Ah, great. Good solution. And a non-lethal one, too, which is interesting. I say as I get cheaped on the head. Also, sound is dead. Let me fix that up quickly. We've been good for the last few hours on this stream, despite a lot of note-taking silence earlier, I suppose. Okay, we should be back with sound. I was about to say, this segment shouldn't be hard to recreate, and then of course we're running into everything we've forgotten by this point. Alright. Everything here should be pretty simple to retrace, though. As long as we're not too careless about it. And then double bounce. Very nice secondary boot there. I wonder why I didn't run into that previously. That little bounce there. I don't know what I did differently. But I guess we'll discover some of these tricks as we go. Those boot hitbox overlaps certainly do have a way of tricking you out. Okay, that seemed alright. I guess I was just doing a slow walk off, and that was perhaps the only notable difference there. Right side this time. We got checkpoint 2. Let's run off here. I was thinking surely it can't just be a high bounce off of that, because you must hit something. I guess we're probably going to hit the Goomba on the split if we do things that way. Except this time the boot was present, so who knows. Okay, so previously we did kill it on the split, but then I guess respawning from checkpoint might have created some kind of critical difference. Yeah, no, that's a death at checkpoint thing, where you reload and then it lets you through, so wondering how the clear check route works out, but it's a troll. It's probably something from the very beginning, for all we know. And that kind of tricks you into thinking that it'll be the same because you don't want to high bounce into the spikes, but then that should have been a comparatively obvious one. But I still need to see how some of these setups work out from time to time, I suppose. Now, why would we want to do that? Okay. Oh, because you lose SMB2 if you do that. Okay, and you need SMB2 for the high jump. That makes sense. What if we kill this guy? Okay, that's what happens. Now we know. So, SMB2 high jump trickery incoming. Oh, whoops. I held jump just a little bit too early before I was actually off the edge of that platform. Not the brightest thing that has happened. I probably didn't need to destroy this stuff, but I think I just run into this. Grab SMB2. There we go. Yeah. And there's going to be some kind of trickery here. No doubt. Whoops. Oh, interesting. That it tricks you into thinking you'll be constrained by the one-way panel on top, and that is actually slightly outside your hitbox, which is not what I expected, but yeah, just hitbox nuances are things that some troll makers seem to have an extremely fine grasp on. We probably don't want to grab that, we'll just high jump. Maybe. Okay, so we got that. And then do we want to do a throw here? And then we wanted to jump back out to get up through the top. Yeah, that's pretty sensible. Okay, let's try this again. Once again, I hope I'll be able to stay through to the end of this, but it's not guaranteed at this point in the stream. Navigationally, though, this is at least fairly simple to work with. Oh, nope, we needed to stand out of the way. Okay, fine. That's it for that one. I guess we'll just take the dive. We're past CP2, we should be fairly close to the end, so I do want to close this out, but we shall see. So yeah. Drop the icicle. Drop this guy and go up. Oh! How did that happen that time? It's been something a little different every time. I did manage to get to jump out of it on a previous occasion, but because it's pretty clear what the exit is supposed to be there. It's just a matter of getting tricked out by everything surrounding that entry point. Yeah, because you're standing on a cloud. Okay. This seems like a little bit of trickery here. Yeah, because you needed to drop the Goomba in that location in order to have something to stand on. Or at least it makes it look that way. Oh, interesting. I don't think that's going to get me anything, though. It's not going to be within range. In fact, that's just a little bit of trickery. Yeah, you'll have to go as well. Well, thank you for joining me, Electro Dude. I'm glad you saw the clear that really mattered here today. We should have considered going back around, actually. With that bone shell. We probably could have gotten back up top. And Electro Dude, once again, thank you for letting me know about that Grisco Stringer session in Splatoon's Resalmon Run. I did get to try it a little bit, and still didn't make much headway with the Kohozuna. I've been professional +2. Thank you for the follow. Look at this block here. What is that block? I don't know. So, Goomba here, we don't want to pick it up in a way that drops me into the bone shell. So is it just a matter of picking it up off center? I think it is. It is. And we have to be very quick about this because otherwise the trampoline will come out of the blaster. Yeah, you don't want to stand there for too long or you just get bumped. No. Okay, what's the flagpole troll that we're working with here? Stunlock. Followed by Magikoopa, okay. Very nice. I guess it must have been a Crush Death that was simultaneously dropped down a track with the Goomba there, because it was an instant kill on the SMB2 Mushroom. It looks like it was a Crush Death. So basically we need to avoid the Stunlock in that final section, and we need to figure out how that's going to look. So I didn't really get a good look at what my options were with that Goomba. I think I probably just needed to pick up that Goomba, actually, and take damage with it. And avoid getting stunlocked during the ride. Hard to say. Haven't had a good look at it yet. We'll need to go back there, perhaps, a few times to do a proper reading of that obstacle. Nope, once again, just slipping a bit. Getting a bit impatient, perhaps, to get back to where we once were. Anyway, it should be fairly simple to get back there, though. Need to be careful, but nothing is too demanding here on mechanics or memory. It's just a matter of not losing your sense of attention. Okay. Stand to the left. Kick this. Drop this. Inch over and go immediately. So we can't really fall back towards the one-way panel, or can we? Maybe we can. In general, the stunlock is going to be an issue if I land on a Goomba at all, right? So I feel like we hit this, and then we just go, and that's a clear. Oh, we did technically find a balloon room. I don't know if there were additional secrets that were buried in here, but I think we're satisfied for today. We'll definitely look at the comments for this one. And yeah, love that Goomba face up front. That's very fancy. Here in the pixel art. I don't know if anything else is accessible. We found a balloon room. I'm content with that. Worked out pretty well as a kind of more or less linear series of Trolls Barnstorm, really bringing the artwork here with a version of the Goomba face. And yeah, a lot of little hitbox trickery. Street Rat kind of bringing it as well with this. Is that a peanut on his head? I think it is. That GG. Maybe it's supposed to be a lit candle. I don't know. It kind of looks like a peanut. Thank you for the follow. And yeah, pretty gentle experience. Like I was saying, it seems like a lot of the troll makers coming into 7MMC were given fairly specific instructions to make a good, approachable on-ramp into the troll genre. So you can see here, nothing too navigational challenging going on, just a series of little things that throw off your expectations, and lots of deleted comments. And some not deleted comments. Is this a sequel to a Goomba movement from 2-3 years ago? I have no idea. It's pronounced a Botan. Okay. Alright, we've had our fill. So, thank you so much for joining me for part 2 of what really did need to be split into 2 segments this week, of 7MMC being the longest by a long shot, especially with our probably 4 to 5 hour experience with the decoder level earlier, especially with having to retread it many times. So for those who stayed and decided to watch, thank you so much for your patience with me today, and I hope that the experience was at least somewhat visually comprehensible. Like I said, we will not get to the bonus level today, 69MMC, but I'm hoping to squeeze in viewer levels later in the week. Probably with the same pattern of viewer levels plus MMC as last week. Although that will depend, because I'm hoping to dedicate as much of this week as I can to completing more of Return to Monkey Island, which we've just barely started, really, on a stream last week. For now, though, thank you so much to all of the makers involved in this week's selection. All 17 of them, if my count is correct, because there were the other 7 and then the 10 on the troll level. So congratulations to all of you on uploading levels in such fine condition, and I hope the streaming experience across many channels has been highly satisfying. With that said, we're going to send you folks off to a raid. So thanks for watching once again. We'll determine our destination very shortly, and we'll see you soon for Mario Maker, Monkey Island, and who knows what else. Until then, have a wonderful week ahead of you. Enjoy the levels, and fare thee well.